this entire content of the Cisco software-defined access in a network is going to be like divided into a few, parts. We'll be using them to complete our content. The content will focus like specifically on the enterprise campus area network, how to build like modern enterprise campus area network. How can we build the LAN like enterprise network based on the SDA Cisco software defined access technology. So we are going to first of all, we are going to talk about like basics, like we'll talk about all the basics of the SDA, like what is SDA, why we need software defined networking, what other solutions are there, what other things are there regarding this SDA, what other software defined technologies are there in the network. And once we are done with that, then we will talk about the components of the SDA. We'll talk about the components of the SDA, like the layers and all those things, the devices that we need. And then we will one by one, we'll try to like implement all these things in the lab environment. So for Cisco software defined access, like there is no, again, there is no official content. There is no official content for Cisco SDA. There's no official certification exam for Cisco software defined access at the moment. Like from the Cisco itself, like the content that is focused on is going to be specific to the CCI and EI enterprise infrastructure. So what things you should know from the SD-Access point of view, let me give you the idea of like what things you should know from the Cisco SDA point of view, specifically the SDA point of view, right? So what Cisco wants you to know, Cisco wants you to know at least about like these things from the Cisco SDA point of view. So go to this Cisco Enterprise exam, and here software defined infrastructure, and here this is what they want you to know from the SDA point of view. This is the content of the software defined access that they want you to know, and that is what we are going to cover in our classes as well. Right. This is like the this is from the current content, and the new content that will be launched on 20th September. So let me we will be covering that one. So let me show you like what exactly is the content that we are going to cover from the SD-Access point of view. So this is what we should know from our current content point of view regarding the Cisco software defined access, and from the new content point of view, the new things that we are going to talk about. Let me show you. This is what we should know here. So what should you know from the Cisco software defined access point of view? These are the things that you should be aware of from the Cisco SDA point of view here. Cisco SDA. So like I said, there is no dedicated certification exam for the Cisco software defined access. There is no dedicated certification exam for Cisco software defined access. So the part of the Cisco software defined access comes under this CCI enterprise infrastructure lab. So this is the content that you should be aware of. So Cisco SDA, first thing you should know, what is the underlay network, what is the overlay network, how to create the underlay network using different concepts, how to create the overlay network using different concepts. So some underlay concepts such as manual underlay, automated underlay, what is this PNP, how can we discover the devices, how can we manage the devices, what are the types of devices that we have in our underlay network, traditional devices, SDA devices, special devices such as extended node, policy extended node, basically different devices that are used to build the underlay infrastructure, all different types of devices that are used to build the underlay network, right? And then once the underlying infrastructure is built, once the reachability is there in the underlay network, then what components are we going to use from the overlay point of view? What things we are going to use from the overlay point of view? Right. So first underlay we will talk about, then we'll talk about the technologies that we are going to use to build the overlay network, technologies such as Lisp, technologies such as BGP, VXLAN, CTS, Cisco TrustSec, Layer 2 flooding, multicast. Like these are the things that we should know from the overlay point of view. Right. So underlay is there, overlay is there, and the combination of the underlay and overlay is what we are going to refer to as the fabric. So how can we design our fabric network? The fabric like single site fabric, multi-site fabric, fabric in a box. Like design the SDA fabric in a single site, design the SD-Access fabric in a multiple site. And what is this feature called fabric in a box feature? Right. So we'll talk about that. So these are again, these are going to be like from the theory point of view, like underlay, overlay, fabric design, how to design the fabric. And then we will be building the underlay network using configuration commands manually. Then we are going to see how the DNS center, how the Cisco SDA controller is going to build the underlay network for us. Then we will see how the overlay network is built in the Cisco SDA in an automated fashion. And then we will design the sites. We will design like, okay, different geographical location sites and all those things we are going to design. Then from the deployment point of view, how can we do the host onboarding, authentication template, port configuration, multi-site border priority? How can we add the devices to the fabric, then handoff, then segmentation? Like the entire content, like entire SDA content is divided into these six, in total in six, chapters, 6 modules, whatever you say. Right. So the content is specifically going to be focused around that. Right. Remember, this is not a DNS center training. This is Cisco SDA training. DNS center is the controller that is used in the Cisco software defined access. DNS center has a lot of options, tons of options. Basically, we are going to be focusing on these options specifically. We'll talk more things, like, for example, we'll talk about wireless. We'll talk about how can we add on the WLC and all those things. We'll talk about that. But we are going to focus more on the things that are specific to our content of CCIE Enterprise Infrastructure Lab exam. Again, there is no dedicated certification. There is no dedicated certification exam for the same. There is no dedicated certification exam for this. So we have to rely on the content in this CCIE EIE blueprint. However, there is an official book from Cisco that we can refer for our knowledge of the Cisco SDA. And that official book it will be shared to you via the portal as well. You can refer to that book, and you can use that book to actually, cover all the things regarding the Cisco SDA. And the book is something like this. So this will be the book that will be shared to you, right? This book is going to be shared to you. This book is Cisco Software Defined. It is not an official certification book because there is no official certification actually. This is just a book to cover the Cisco Software Defined Access. And it focuses on these parts. It focuses on all these chapters. Let me show you. Here. There are total 9 chapters in this book, which are sufficient, which are enough to actually cover everything from the SDA point of view. So today's network and drivers of change, like what are the challenges in a modern day network, and how can we overcome those challenges of the modern day network? Then what is Cisco software defined access? How Cisco SDA deals with these modern day challenges, right? What is the controller used in the Cisco software defined access, which is what we refer to as the DNS center, which has been renamed. It has been renamed to the Catalyst Center. It has been renamed to the Catalyst Center nowadays. Very recently, they have renamed it to the Catalyst Center. Now, anyway, so the controller that we use here, called the DNS Center controller, DNAC in short. So what is the DNS Center? How the DNS Center is basically going to integrate in your campus network, all those fundamentals from the DNS Center point of view. What is DNS Center hardware? How does it look like? From where we can purchase and all that, licenses and all that thing is going to be covered in chapter number 3. Once it is done, then we'll talk about the SDA fundamental, the protocols, Lisp, VXLAN, BGP, all those things, all those protocols we'll talk about here in chapter number 4. Then when it comes to authentication, when it comes to Cisco TrustSec, we use Identity Services Engine. So there is one chapter for dedicated like ICE. We'll cover whatever is necessary from here. So Identity Services Engine, ICE is one of the component of the Cisco SDA. We will see how the ICE gets integrated in the Cisco SDA. We will see how the ICE gets integrated, in the Cisco SDA solution. Right. We'll not cover like complete ICE, deployment and everything. It is dedicated part of the ICE training. We'll talk about like how ICE gets integrated with the Cisco SDA. We'll talk about basic components of the ICE, and then we will see how the ICE is going to be integrated in the Cisco SDA. Then is the operation and troubleshooting, advanced topics such as multicast, like, L2 border, L3 border, and all those things, some advanced topic. Advanced topic regarding the Cisco SDA and advanced topic regarding the Cisco DNA Center. And at the very end, monitoring, day-to operations monitoring assurance. So there are approximately like 300 pages, 305 pages that you need to cover. And there are total 9 chapters from the SDA point of view that we can go through. This is one book. This is also one book, which is which goes something like that. This is also another book for the same. It is much more concise. It is much more precise. Like if you want to just go through in brief about like what is SDA, all those things. So this is much more better than the previous one. So this book covers like all those things, all those topics that we need to know from this SDA deployment point of view. It is only 158 pages. So you can also cover like things from this book as well. This is pretty good book actually to cover, all those things. Both the books will be available to you onto the portal, and we will be using this book to cover this entire content that is present, that is here in the Cisco SDA. This is the content that we are going to cover. Let me show you the content. This is the content that we are going to cover here. This is the content that we are going to cover. So introduction to Cisco SDA solution. Why software-defined networking, SDN solution, what SDN solution Cisco is going to offer, how we can integrate all those different SDN solutions such as SD-Access, SD-WAN, and ACI Epic. Cisco SDA solution, use cases, features, migrating from the existing to the SDA network. So basic like SDA solution, we'll talk about that. Then from the architectural point of view, what things are there from the architectural point of view in the SDA? So SDA physical layer, network layer, controller layer, management layer. We'll talk about the physical layer in detail. Devices at the physical layer, Catalyst 9K series platform, iOS XE, intermediate nodes, extended policy nodes, roles of devices at the SDA physical layer. Like what roles we can set on the devices at the physical layer. Edge node, border node, control plane node, external, like we'll talk about all these things. And then fabric in a box feature where we can set all the roles on the same device. Right, then the network layer, the components of the SDA network layer. Here we will talk about the underlay, overlay, how the underlay network is built, how the overlay network is built, how can we build the manual underlay, automated underlay, overlay, and all those things. We'll talk about that. What are different protocols such as Lisp? What is different like VXLAN? What are the different protocols to build the SDA overlay network? Protocols such as Lisp, protocols such as like VXLAN, protocols such as Cisco TrustSec. So network layer is going to include the network layer in the SDA is going to include all the protocols that we require to build the overlay network. Protocols such as Lisp, protocols such as VXLAN, protocols such as Cisco TrustSec. Then the controller layer, like the DNS center and ICE, DNS center hardware appliance scale, how many DNS center appliance we need to manage a small, medium, and large scale network, cluster, subsystems, like inside the DNS center, then correlation between these subsystems and CP and NDP in the DNS center. Then ICE, Identity Services Engine, which is also a component, which is also comes under the controller layer in the SDA. Then the management layer, where we can, management layer is basically the UI. How are we going to access the user interface? Are we going to actually use the graphical user interface, or are we going to use the APIs? How are we going to actually access the interfaces of the DNS center? Then how can we deploy the SDA in a distributed campus? We'll talk about that. This is the theory part. Once the management layer is done, theory will be done. And then we'll talk about how to deploy the SDA in the network. We'll talk about like how to create the sites, domains, connectivity between the sites using the IP addresses, IP transit, and other types of transit. How to create the fabric, like where do we need to create the fabric? What is the concept of VM, VRF? We'll talk about that. How can we onboard a user? How can we have the DHCP, DNS, NTP, syslog, SNMP, all these services from one centralized point? Basically the fabric creation and host onboarding we are going to cover in this chapter. Then advanced SDA topics such as like tools, different tools that are available in the DNS center. How can we manage the licenses from one point? What is this LAN automation? How can we enable the multicasting in the SDA network? the flooding, layer 2 border, intersite, traffic flow, template editor, PNP, like the advanced topic of the Cisco SDA and the DNS center, and then the wireless, like how a little bit of wireless. How can we actually add on the wireless in the SDA? WLC access point, initial onboarding of the Cisco wireless LAN controller in the SDA. How can we create different pools and templates in the SDA? How to enable the wireless in the SDA fabric. Then we'll talk about like the assurance, which is this day two operations and all those things. Like how can we use the DNS Center user interface to perform basic troubleshooting monitoring from one centralized point. Right. So this is the content that we are going to cover from our SDA content point of view. And at the very end, we will have the labs. Like these are the labs that we are going to cover as a part of our content. Approximately 20-25 labs we are going to cover. We will see the installation process of the DNAC, initial configurations, role-based access control, settings and overview of the DNS Center graphical user interface, then create the site, create the network settings, create the underlay network, device discovery, assign the device to the site, device provisioning using the provision tool. What is this LAN automation? How can we implement the LAN automation in the network? Assign the rules onto the devices, fusion router configuration, border node config for the border node, layer 3 handoff, host onboarding, port assignment, DHCP, authentication template, creating the virtual network, scalable group tag, and policy is like, security related policies in the policy workflow. Multicast, how can we enable the multicast in the SDA, template editor, wireless LAN controller onboarding, wireless profile, API, and finally the assurance dashboard. 20-25 labs, small labs we are going to cover in our SDA. We are going to use we will have a traditional network built around EVNG. We will have one Catalyst 9300 series switch for branch 1. We will have 3 Catalyst 3850 series switch for branch 2. We will have one DNS center, one ICE, and one wireless LAN controller for wireless. These are the things that we will use from the device point of view. We will have a topology. That topology will have like traditional network, and it will also have the SDA network. The combination of both we are going to use. Right. So this is the entire content that we are going to cover. This is the entire content that we are going to cover. Right. It is as per our official documentation. It is more than that actually, but it is going to include all these things. It is going to include all the topics that we have as a part of our official Cisco blueprint. Right. So we are going to use that to cover these topics. We will be using the same book that I have shown you. That book you can refer to actually to cover all these topics in more detailed way. Right. So this is what we are going to do. Right. Now, okay. A few more things, like how long it is going to take to complete like this entire content. Let's talk about that as well. This entire topic, like all these topics, how long it is going to complete like this entire, content. So from the content point of view, specifically from the, the content that we have just discussed, specifically from that content point of view, we will be discussing about the wireless and all those things in not that much detail, but apart from that, from the dedicated content point of view, it can take approximately total 15 to 16 classes total, 15 to 16 classes. In these in 15-16 classes we can expect to complete our content. Right, maximum 15-16 classes will be required to complete the entire content. Right, so this is one of the previous batch where we have talked about all those things. So you can see that 15 classes are approximately there. 15-16 classes, 16 classes you can conclude, 8 weekends it will require to complete all these things from the lab and theory point of view. Right, we will be using a dedicated topology for the lab. I will show you the topology later on, but we'll be using that topology, and using that topology we'll be completing all the entire lab. And it will take approximately like 15, 16 classes in total. Right? Okay. Now, as far as the labs are concerned, like since this SDA technology is built around the physical devices, like we cannot actually simulate these things, in a virtualized environment such as even GNS and all those things. We will not be able to you will not be able to do all these labs like in your home environment. However, what you can do, you can utilize this D cloud. We'll talk about that. You can utilize like this D cloud. You can log into Cisco D cloud. You can just search Cisco D cloud, and in the Cisco D cloud, here you can search the Cisco D cloud. You can go to Cisco D cloud. Here you can log in with your Cisco credential. You will log in with your Cisco credential, and I'm not saying that you will be able to do everything, but most of the things you will be able to do and explore like from this D cloud itself, right? So you will log into the D cloud, Cisco D cloud. Once you have logged into the Cisco D cloud, you will go to like this, main home page. Let me just open. Let this open. It takes some. So you go to the D cloud. On the D cloud, you just go to this option called catalog. In the catalog option, it will open like the demo of a lot of products. You can click on this D cloud. You can click on this instant demo and see right here, the very first one is Cisco DNS Center version 2.3.5.0. Right? You can just click on this view button here, right? And it will directly open. Like here, from here, you can directly log into the DNS Center version 2.3.5, and you can do like quite a lot of things on here, right? So you can click on this button. Like you will require the user ID password to log in on here. Where are those user ID password? So here you can go to like the user ID credential is demo 1234. So you can use this user ID password to log in into this DNS Center. Right. So you will use that user ID password and you will log into this Cisco DNS Center, which is provided onto the cloud portal. Right. So here you can just go to the catalog. The very first option here, you can see here we have this option of Cisco DNS Center. You can click on that. And once you click on that, it will open this page to provide you the user ID and password information. And once you get the user ID and password, you can just log in here. You can just check the things here. So this is the DNS Center version 2.3.5. You can confirm it from here in the help about option. It is the version. Where is that? It is 2.3.5. They are not actually showing us the version actually. Of course, they will not. But the point is that this is version 2.3.5, right? So you can open this here and you can see like a lot of options here. You can like we will be using like same set of DNS Center. So you will notice that whatever things I am be doing, you can do all those things here itself. Like, I'm not saying that you will be able to do everything, but 50, 60%, 60% content, you will be able to completely do right here itself. Right. So for example, we can add an area like, when we do the lab, I will be doing the lab on my own machine. And here, I will be, you can do all those things like on here. You can do all those things here. No, DNA analytics content, like, no, we are not going to use that. We are not going to, cover that AI or ML feature. Like from the analytics point of view, we are just going to talk about the assurance. In the assurance, we will have the basic monitoring and all that. We will not talk about like the AI, machine learning, or even these third party, like, for example, or when we talk about the APIs, we will not talk about like everything from the scratch, because the API content is specific to this DevNet certification and all those. So we'll be using just basic, we'll be doing some basic API calls to get variety of information from the DNS center. And like we'll not be covering like, APIs and all those things from the very scratch. Right. So AI and those topics are actually, we will not be covering on here. The content is very specific. Whatever content we have discussed, we will be covering only those contents. Like the content that we have just discussed, we'll be covering those content. It will not include like any additional things such as artificial intelligence or machine learning. Currently, at the moment, there is no a software available for this. There's no virtualized way of implementing the same. Like they might be using something, who knows, like what Cisco is using in background. But the point is that at the moment, like this DNS center has not come up with a resource that has not come up with an image that we can run on simulated platforms such as EVNG. We can deploy this in the VMware if you want, like, but the VM, the server where you are going to deploy this DNS center, that server has to be like a very well resourced server. So if you have that good server, like, then you can deploy this into your home environment. Otherwise, like, you will be dependent for the labs on this portal itself, on this dcloud portal itself. Like a lot of things you will be able to do from here. A lot of things you will be able to do from here. I'm not saying that you will be able to do everything. I'm not saying that you will be able to do everything. I'm just saying that a lot of things you will be able to do, like most of the things you will be able to do from here. Right, so that you will get the idea. You will get the idea of all these things from one point. From the lab point of view, you will have the idea about like all the things. Right? Okay. So I will be using, of course, we have a DNS center here on the premises. Now I will be using all these things. We'll be setting up the DNS center from the very scratch, right? And you, for the labs, you will be relying on this dcloud DNS center, right? Here you will have the fixed devices, fixed topology and all that. You will not be able to create your own topology or something like that. But apart from that, you will be able to do like, you will be able to explore most of the options here in this dcloud portal itself. Okay. Our focus will be on the SDA. This is the DNS center. Our focus is going to be just one part of this, which is SD-Access. Our focus is going to be just on one part of this entire DNS center, SD-Access. Of course, we'll talk about like design, policy, provision, assurance, but we are going to focus more on this SD-Access. This is an SD-Access training, just to repeat myself. This is an Cisco SDA training. It's not a DNS center classes. So we will be not talking about like each and every option that we have in the DNS center. We will talk about like as much as we can, but we'll not go through like each and every option that we have. They keep adding like, different features. Not even the proper documentation might be available at the moment. So it is just not possible to, go through like each and every option that is presented here. So we will keep our focus specific to this SD-Access, right? How to create the VM, fabric site, transits, and other things. But of course, we'll go through all these options as well, but not like everything. Okay. Now, before we begin our classes, you should have the basic understanding of campus design. Means like you should know, for example, like what is switch, what is switching, how can we, create a 2-tier, 3-tier design in our campus area network. Basic switching idea you should have. If you have the basic fundamentals of switching cleared, like STP, VTP, DTP, all the basic things, if you have cleared, then you are good to, go with these classes. We will be talking about like the core layer, distribution layer, access layer. You should have the idea what exactly is the core layer, what is the distribution layer, and all that. So it will be easy to cover the content within the given time period. Right? Okay. Any questions so far? Anyone? Let me know. You guys, any question if you have, let me know. You can unmute and ask the question just in case.
Hello, sir.
Yes.
Actually, I was not able to log into using that portal, so I just logged in. So, can you please quickly give me
We
an
have just
overview?
discussed. We have just discussed the content. We have not discussed anything else. We have just discussed like what we are going to cover and how we are going to cover that. You can refer to the recordings for the same. We have
Okay.
just covered like what we are not started the content yet. We have just talked about like what we are going to cover.
Okay.
Any question, anyone? Let me know. Ashish, you are not audible to me just in case if you are saying something. Yeah, sure, unmute. You can unmute.
Hello, sir.
Yeah.
Sir, this Cisco DNA Center is a web-based software, right? Or a web service like cloud.
We will talk about that. We'll talk about that. What is DNS Center? It is basically hardware that gives us the GUI access. So we need to purchase the hardware from the Cisco. Nowadays, it is also possible to install it in a software. So we'll talk about all that later on, like in detail, like how to take the access and all that thing.
Okay.
Sir, one more thing.
Yeah.
So, is this these recordings we can refer from the earlier portal, or is there any new portal?
Same thing, same. From where you have joined, same portal. Ask your like account handler to assign you the course and everything so that you can join the classes on regular basis. And you can get the recording exactly in the same way as you were getting the recordings earlier.
Okay.
Yeah.
Okay.
Yes. Shresh, you are still not audible. Remove the mic set. Remove the mic. Microphone.
Hello?
Like yeah. Now you are audible.
So content you have mentioned in the previous that we will be discussing about the use cases of ICE. So we will be discussing about the use cases of ACI also.
No. Only like we will just focus on the DNS center, and like when it comes to like ICE, we will talk about like how ICE gets integrated with the DNS center, and like different services that runs on the ICE and all. We are not going to talk about ACI or Epic.
Okay.
DNS center is specifically for the campus network. So ACI and all those things are like from the DC point of view. Our content is going to be specifically focused on the enterprise LAN automation, enterprise like campus, like modern day campus network design using the DNS center. Yes.
Campus network observability.
Yeah, that is from the DC point of view. So again, like that will be covered someday in DC track.
Campus network observability and inside is the DC point of view.
Which one? This one, this DNS center.
No, I'm talking about the use cases of DNS center. That is campus network observability and inside and campus network automation. I think these are the part of the network.
Yeah, we can manage our see the point of the use case of this DNS center is to manage the switches actually. Like if you have installed some switches even in your data center and you want them to manage like the IOSXE based switches, and you want to manage those switches from one centralized point, you can use your DNS center. So specifically, we'll be talking about from the enterprise network point of view, not the DC point of view. In DC, we typically have those, Nexus switches, and also data center will be used like here. In our case, the use case will be limited to like managing the enterprise campus devices.
Okay.
We will see that. We will see, Shudhanshu, like, yeah, SD-Access, like DNS Center gives us the facility to manage all these things from the GUI point of view. How much CLI will be left, we'll talk about that as well. Like, again, you will need to do some basic configuration. You will need to make your switches reachable to the DNS Center. Otherwise, how the DNS Center is going to manage all that. So some configurations are still required. We will talk about those, like, what configurations are required still. But it's not like going to completely replace the CLI. No, like there is no, see, switching like is not going to end anytime soon. Like neither the SD-Access is going to end. It's like just the way we are going to perform things are going to be like different. Like the design, the traditional network design is still going to be there in some places. The new SDA design is also going to be there in some places. Like traditional one can communicate with the DNA one, like enterprise one and all that. Why people are saying that the switching will end? Because of this DNS center. Since we are using this DNS center to manage all the devices from one centralized point, let's first talk about like what is the Cisco SDA. What is basically software defined networking? Let's talk about SDN. What is software defined networking? And what other SDN offerings are there as well apart from this Cisco SDA? So first of all, let's talk about like SDN. So in a modern day network, like we have our traditional devices, like, we have our router switches all deployed in branches, headquarter, data center, all the places. Now, one of the biggest challenge of like, having all these router switches in a campus network, in a data center, in a headquarter, is that how are we going to manage all these router switches, firewall, all these devices one by one? If there are like a lot of devices, if there are like a lot of routers, a lot of switches, a lot of like, devices to manage, the device management is going to be quite time consuming. Most of the networks, like, they use some configuration management tools. Most of the networks, they use some configuration tools to manage, to do all the configurations. But those configurations tool, like, they might lack quite a few features. Companies, they might have different tools to manage their infrastructure devices, and those tools might lack some features, as compared to other tools as well. So the point is like here, in a traditional network, when it comes to the traditional network, one of the biggest challenge that we face in a traditional network is like, how are we going to manage all the devices of the traditional network, like all the switches, all the routers? Every device, like, every device has its own, if you remember, every device has its own management plane. So what we are going to do, we are going to connect to this device. We are connect to, like, if there are n number of devices, we are going to take either the console access, we are going to take the SSH telnet based access. Basically, we need to manage all these devices all by ourselves. There are many challenges in a modern day network. There are many challenges in today's network, managing the network because of manual configurations and fragmented tool offering. Fragmented basically means like different vendors, they offer different tools to manage different devices. If a company is more like a company that has been using like multiple vendors, they might need to use multiple tools to manage multiple devices. So say that there are many challenges today in managing the modern day network because of manual configurations and fragmented tool offering. We do the configurations manually on the devices. Manual operations are slow, prone to errors, and they are proving to be very ineffective. The number of devices that we need to manage all like one by one, all by the configuration commands. Like if we have a large amount of devices that we want to configure, the entire operation is going to be very slow. The administrators might make some configuration mistakes, which might cause some issues on the network as well. So configurations are error prone, and they are proving to be very ineffective for the modern day network. With the growth of the users and different devices types coming into the network, let's say, for example, there are n number of devices, and on all those n number of devices, we need to set the username and password so that the administrators can log in onto those devices using telnet or SSH. configuring the username, password, user credentials on all the devices by ourselves, then changing it maybe in 1 week time period. So, just for the security, from the security point of view. So configuring the user credential, and maintaining this consistent policy across the wired and wireless network is getting more and more complex. Modern day network modern day network is not only built around the wired infrastructure, but it also includes different wireless devices such as access point, wireless LAN controller. So we need to have a policy. We need to have a policy for the user that connects via wire, that connects via some sort of physical wire to the network, and we need to ensure some policy for the user that uses wireless technology to connect into the network. So a different policy for the wire user, a different policy for the wireless user. We need to configure the user ID and password on the router, switches, firewalls, all these devices, so that the users can log in, to the devices as per the requirement. The rate at which changes are happening, the pace at which the changes are happening, it exceeds human scale. So again, there are different challenges that we face in a modern day network when it comes to managing all the devices, such as routers, switches, firewalls, and the other appliances, wireless LAN controller, access points, and all those. If we, for example, categorize all these challenges that we have in a modern day network, we can categorize these challenges in the challenges that are related to the network and the challenges that are related to the security. So there are certain challenges that can be categorized as network operations related challenges, and there are certain challenges that can be categorized as the security related challenges. Security related challenges such as user ID and password. Security related challenges such as, I want to control that this device should not be able to communicate with this device. This device should be able to communicate with this device. We can create things such as VLAN. We can create things such as ACL to control like what devices can communicate with what devices. Which devices can communicate with which devices can be controlled with the help of things such as VLAN, can be controlled with the help of things such as access control list. However, in a large enterprise network, managing the VLANs one by one, managing the ACLs that has maybe thousands or tens of thousands of statements, is again going to be quite time consuming, quite hectic task. When it comes to network operation challenges, again, managing all the devices from one point, deploying like a number of devices in different locations, configuring consistent policy for both wired wireless users. Like a lot of challenges you might face when it comes to network operations as well. So the bottom line is that the networks of today do not address the today's business needs very effectively. And also the companies might not be dependent on single vendor. Companies might be using different vendor devices. Companies might be deploying their devices onto the cloud maybe. Like nowadays, cloud is also very much in fashion. So companies instead of deploying the devices into the premises, companies might deploy the devices into the cloud as well. Who knows? A lot of challenges, like I said, a lot of challenges we are going to face in a modern network. Every device that we have has its own set of control. It has its own control plane, management plane, data plane. So if we want to manage a number of devices, we need to connect to those number of devices one by one. We want to configure some maybe routing protocol. We need to configure the routing protocol on all those devices one by one. Right? All these devices that we have, they have their own set of control plane, management plane, data plane, because of which, like the things such as routing protocols need to be configured on all the devices one by one. Like device management needs to be done one by one. Every device is going to take a look at its own routing table to decide how the data forwarding will take place. Right? How are we going to manage the devices that are wired devices? How are we going to manage the devices that are wireless devices? A different policy for wired user, a different policy for wireless user. Too many policies to handle. We are going to deploy like a number of devices in the network and in different geographical location. And all those devices need to be configured with, let's say, some GRE tunnel, some DM VPN, some IPsec. So some administrator need to configure all those things on all those number of devices one by one, which is going to take a lot of time. So there are going to be like deployment related challenges. There are going to be like management related challenges. There are going to be like security related challenges, VLAN, ACL, and all those things. And once you have deployed everything, once you have configured everything, once you have deployed everything, maybe someone is reporting that I am not able to access the network resources. Right. So you need to now do the troubleshooting. So you might need to do the troubleshooting on those n number of devices, all one by one. So operation related challenges, like once your network gets completely up and running, then there comes like a lot of operational challenges as well. Your network is up and running. Suddenly a user reports that that he is not able to access the services. Then you require to reshoot the network using again same commands and all. So again, some operational challenges are also going to be there. And let's not even talk about the modern day network getting connected to the cloud. The modern day network using like multiple vendors, like different vendors can have different softwares to manage the devices. Like in some vendors, for example, we can use like STP. In some vendors, we can use PVST. How the interoperability and everything is going to be there. Right? A lot of challenges are there in the modern day network, both like LAN side of the network and the WAN side of network. Not only the LAN, also the WAN side of the network. There are different types of challenges. Okay. And these challenges are not only specific to the enterprise network. These challenges were also there in the data center network, in the headquarter network, in the branch offices, like different places. These challenges were actually faced. So they decided why everything need to be done, why everything is needed to be done from the like human point of view, why we should do all these things from configuration commands and all those things. Why should we do all these things? Why don't we build some softwares that can do all these things for us? Why don't we build some softwares for the same? And that is where this software defined networking came into the picture. The birth of this SDN, like software defined networking, was there to overcome all these challenges that actually we were facing. And these challenges were addressed for the very first time. All these challenges, they were addressed for the data center network itself. A data center network, if you talk about the DC network, if you talk about the data center network, like all these challenges that we have just talked about, installing the new devices, enforcing the security, doing the configurations, user ID passwords, and all those things. All these challenges were being addressed, all these challenges were addressed in the data center network, first. Right. So networks, modern day networks, they cannot respond quickly to evolving business needs if changes need to be done manually. Such modifications take a long time and are error prone. Let's say you are to be you want to do some configuration changes. You might need to take the approvals from a few authorities, and then you will proceed with the changes. You will do the changes manually by the configuration command. And maybe you have executed incorrect configuration command, so that has not resulted in proper output. So networks, modern day networks, they cannot respond quickly. These the modern day network should be able to respond quickly to evolving business needs. If the changes are needed to be done manually, it is not going to be a very quick process. Such modifications take a long time and they are prone to errors. Effective network segmentation can be expected in the network. It can exceptionally difficult to achieve in a complex network with a variety of users, devices requiring different access and privileges. So what does it mean? It means that nowadays in a modern day network, we not only have computers, we not only have fixed devices, we have roaming devices such as our mobile phone, we have our tablets, We have, let's say, for example, IoT devices. We have like access point, wireless LAN controller. We have different types of devices. And these variety of devices, variety of users of the network, like humans are no longer the only users of the network. In a modern day network, humans only are no longer the only users of the network. We nowadays, like applications or machines are users of the network as well. For example, we have some IoT sensors. For example, we have some, some other devices, CCTV cameras, all those like other monitoring, some monitoring devices as well. The IoT, Internet of Things, for example, has evolved a lot in a modern day network as well. So humans are no longer the only users of the network. There are machines, applications that are users of the network as well. And of course, like we have variety of users in a modern day network. Different types of devices, they require different access and privileges. Of course, like your corporate user should not be allowed to, communicate with, for example, the guest users, and guest users should not be able to communicate with the IoT devices. A guest user should not be allowed to communicate with the corporate users. The corporate traffic must always pass via some firewall before going to the internet, and the guest user traffic can pass directly, and the IoT devices can, communicate with the internet directly, and maybe some devices that are deployed, some applications are also deployed on the cloud. The users are going to access those cloud delivered applications, and everything they should be able to access those cloud delivered applications and things properly as well. So effective network segmentation can be exceptionally difficult to achieve, because in a modern day network, like segmentation is very difficult in a modern day network, because humans are not the only users of the network. Traditional IP address based methods with firewall, VLAN, ACL do not scale well, and they are not very efficient in responding to real time needs. As per some researches, like the ratio of operational expenses to capital expenses on the network operations, labor and tools. Like a company spends like approximately 3 times more in operational expenses as per these capital expenditure. So 95% of changes in the modern day network are still being done manually. 75% of the operational expenses spent on the changes and troubleshooting, and 70% of the policy violations are due to human errors, as per some reports. So modern day, like these traditional networks, they do not address all these challenges that we face in a nowadays network, in a modern day network. If we have built our network based on those traditional 2-tier, 3-tier architecture, and we are managing all those things one by one, this is just not going to work in a modern day network, because of the type of traffic, because the type of the users, because of the requirement of different types of policies, because of the inclusion of clouds in the network and all that. So a lot of like challenges are there in modern day network. And here, like these challenges were addressed, actually, all these challenges actually were addressed in the data center network for the very first time. In the DC network, like in the data center network, these challenges were actually addressed for the very first time. In the DC network, when we talk about this, the data center network, these challenges were addressed for the very first time. These software-defined networking for the same. They started, they say that, okay, why should we configure all these things ourselves? Let's do one thing. Let's include some software's configuration process and all. So to overcome these challenges, everyone decided to use software-defined approach to manage the network, where the engineer will configure its intent and the software will do the configuration automatically to configure the devices based on the intent. Software-defined networking uses some sort of software to manage and configure the enterprise network, the data center network, or the other type of network in an automated fashion. There are 3 nowadays, like there are like 3 offerings of SDN from Cisco. Other like exist as well, but from Cisco, offers like 3 SDN solution in a modern day network. Cisco uses like this open daylight controller. Like earlier, before like all these things, Cisco used to use this open daylight controller. It was Cisco's solution to open SDN controller, which now has been obsolete. Like you are not going to use these in again modern day network. So Cisco offered like this open SDN controller or OSC. This was like Cisco's SDN offering built around the open daylight controller. It got obsoleted, like no one is going to use this. No one uses these nowadays. The second offering that Cisco has is called like ACI, application centric infrastructure, based on EPIC. ACI is the infrastructure, application centric infrastructure, and EPIC, APIC, application policy infrastructure controller, is the name of the controller that is used in the data center environment. So data center uses this ACI EPIC concept. This data center uses this ACI EPIC controller concept to manage the entire data center from one centralized point. Data center network is built around some application. That is why we refer to DC network as ACI, like application centric infrastructure. And that ACI network is managed via this EPIC, application policy infrastructure controller. It worked very well. Like this ACI EPIC concept worked very well in the data center environment. Like, the use case, the troubleshooting and all those things like deployment, management, all those things became like very easy in the data center environment. So they thought like, why don't we use the same thing in the enterprise network? Like this ACI EPIC concept, ACI EPIC, we are using in a data center network. So why don't we use the similar thing, similar concept? Why don't we use in a like enterprise network? So they thought of like using the same like ACI type of like some sort of infrastructure in the enterprise network as well. They thought like, why don't we use like why don't we use some ACI type of infrastructure, ACI EPIC for the enterprise network as well. EPIC is used only for DC. EPIC, application policy infrastructure, is used for DC. So what they did actually, since the EPIC was it became very popular. It became like very popular controller for the data center network. They decided to use the similar type of thing for the enterprise network as well. And they launched a controller called EPIC EM. EPIC Enterprise Module. EPIC EM was Cisco's offering of EPIC for the enterprise network. EPIC EM, Application Policy Infrastructure Controller. EM stands for Enterprise Module. It was their offering. It was Cisco's offering for the enterprise network. Unfortunately, that could not gain a lot of popularity. Now, they also had the if you guys might have heard about it. They had this thing called prime infrastructure. They also had this prime infrastructure as well for the enterprise network. Cisco Prime, yes. Cisco PIE, Prime Infrastructure. Means like a lot of SDN offerings were there. What I'm trying to say is that a lot of SDN offerings were there. People were not that much aware of these things, but it was there. Like things such as like SD-WAN has been in the market for quite a long time. Like we nowadays have some knowledge, some information about the same, but the SD-WAN kind of thing was there in for a very long time. EPIC actually is going to manage all these things in a data center environment. So from the DC point of view, like whatever infrastructure you have created can be managed, we can create like different like policies on physical, virtual, or any type of device in the data center network environment. Not, I think like not specific to the like servers. Like servers, like if you're talking about from that server point of view, yes, like it is going to manage the servers. Inside the servers, we can have in different types of infrastructure that can be managed via this EPIC, application policy infrastructure controller. We can configure different policies. We can configure things such as cost, quality of service. We can integrate like other vendors such as VMware, Microsoft, and other vendors as well. So EPIC is one of the controller, application policy infrastructure controller. It is a part of the ACI, like ACI solution, ACI fabric. If I say like instead of saying that it manages a server only, we can say it manages the ACI fabric. And the ACI fabric includes like different components. So it is going to manage the ACI fabric from one point. And then we can enforce different types of policy as per our requirement on there. We are not talking about EPIC. We are talking about like EPIC EM, like the device that we use to manage the switches actually, not the servers. If you can use this as site to manage like the switches, then it's okay. You can use that, but I don't think like that is possible. What is the difference in like intersite and EPIC? You have to refer to some DC expert for the same. Our aim here is to manage like all these switches that we have in the enterprise network from one centralized point. Right. DC and cloud typically, see, cloud is basically someone else's computer. So from a branch user point of view, DC is a cloud. But again, cloud is some well-equipped data center in one fashion. So DC and cloud, like they are different things. They refer to the different things, but in a way, if you think about it, like DC, a data center that is owned by your company, from the branch user point of view, if there is a server that is installed in the DC, from the branch user point of view, it is just cloud. Cloud is anything that is not on your own local machine. You can access your file online on Google Drive. It is cloud to you. Right. So EPIC EM they created. Now, what happened? EPIC EM did not gain like a lot of popularity actually. Like it could not become like that much popular. Other solutions were also there. People just like the enterprise users, they did not adopt EPIC EM like very well. So they discontinued that EPIC EM. They do not offer EPIC EM anymore. And when later on, when the software-defined networking gained a little bit popularity, they actually repurposed the EPIC EM controller and they launched it with the name of DNA Center. So DNA Center, actually the DNAC, DNA Center, which is a controller that we use to build the software-defined access network, the SDA network for a campus area network. The DNA Center controller that we have, it is actually just repurposed EPIC EM with assurance functionality, better assurance functionality. So no, EPIC EM and DNA Centers are not the same. Like EPIC EM and DNA Center, they are not the same. EPIC EM was an SDN offering from Cisco in earlier days. DNA Center is a modern day SDN offering for the campus area network. DNA Center includes the functionalities of the EPIC EM. It is like more like repurposed EPIC EM with the assurance function. You will notice like quite a lot of functionalities of the EPIC EM are in the DNA Center, plus assurance functions are also there. So they actually repurposed the EPIC EM and they launched it with this. DNS center name. So nowadays, in a modern day network, we have 3 SDN offering from Cisco. We have Cisco EPIC, Application Policy Infrastructure Controller, for DC, for data center network. Data center network that is built around the ACI fabric is managed by this EPIC, Application Policy Infrastructure Controller. Then we have Cisco Software Defined Access SDA for a campus area network, where we are not going to use like servers or so. We are going to use switches that are going to be managed from the DNS center. So the controller that we use here is referred to as the DNS center. And for the modern day wide area network, Cisco has one more offering called SD-WAN. SD-WAN, Cisco SD-WAN based on Viptela and Meraki. It is like for the next gen wide area network. So modern day SDN, modern day networks can be deployed around 3 major SDN solutions to overcome all those challenges. To overcome all the challenges of the traditional network, the modern day networks can be designed around 3 of these SDN solutions. Cisco SD-WAN for WAN, to manage all the WAN edge devices from one centralized point. Cisco SDA to manage all the campus LAN switches from one centralized point. And Cisco EPIC to manage the ACI data center from one centralized point. Right, so here, if we talk about like end-to-end SDN solution, we have SD-Access for our campus area network. We have our ACI data center managing all the ACI fabric from one data center. And then these are connected with the help of these managed routers. These managed routers are again Viptela based router. These are SD-WAN routers, which can be managed from Cisco SD-WAN solution. DNS center can be used to manage switches. What switches? We will talk about that. Are they going to be layer 2 switches? The concept of layer 2, layer 3 switches is no longer, that much significant in a modern day network. Modern day network switches that we have, Catalyst 9K series platforms that they have, you will notice that all those platforms, they support routing functions. So the line between layer 2 and layer 3 switch in a modern day network is actually like, is like very thin nowadays. If you go to the data sheet of a very basic Catalyst 9200 series switch, right, and you see what functions, what things it offers, right, and you compare that same thing like with a old layer 2 switch, you can find the differences between the thing. So like, we'll talk about that, what models are compatible with like, the DNS center. In short, like it's not specific to L2 or L3. DNS center is responsible to manage the switches. What switches? We'll talk about that. Are those layer 2 switches only, layer 3 switches? We'll talk about that. Viptela and Meraki, these are like 2 SD-WAN solutions. Like Viptela was a company that used to provide the SD-WAN solution. Cisco acquired Viptela, so it became Cisco SD-WAN Viptela, or simple Cisco SD-WAN. SD-WAN technology allows us to manage all the WAN edge routers from one centralized point. Right, and Meraki also is you can say Meraki SD-WAN. Meraki also provides the SD-WAN, which is again owned by Cisco. So Meraki SD-WAN for small businesses and Viptela based SD-WAN for medium to large businesses. They offer 2 types of SD-WAN offering. When it comes to the SD-Access, there is only one SD-Access, DNS center based like, SD-Access, and the ACI EPIC based your DC infrastructure. So if we want, we can have like complete end-to-end, like, connectivity from the device to the device based on the SD. Like everything can be managed like using like these controllers. So here we have like a controller called DNA Center. Here we have a controller called vManage. vManage is the controller, one of the controller. It is responsible to provide the GUI, graphical user interface, that can be used to manage all these managed devices. Here, then here we have like a DNA Center. Again, it is a controller that is used to provide the GUI, graphical user access, to manage all these campus switches. Then we have like EPIC, Application Policy Infrastructure Controller, which is responsible to manage the ACI data center. So 3 different controllers to to manage 3 different types of network: WAN network, Viptela; a LAN network, DNAT; and the data center, EPIC. All 3 of them have different graphical user interface, right? So vManage graphical user interface is different than the this DNA Center user interface. So if you want to see like how the UI looks quite similar, actually the user interface looks quite similar, but just to give you the idea, this is how the vManage graphical, this is the SD-WAN graphical user, this is how the SD-WAN graphical user interface looks like. You might find this quite similar. You might find this quite similar to this one, like UI, from the UI point of view. From the user interface point of view, you might find it like quite similar, like, to this DNA Center one. Very similar to the DNA Center one. But this is used to manage like these, switches specifically, not only switches. We'll talk about what things we can manage from the DNA Center, but this SD-WAN solution is responsible to manage all the routers from one centralized point. Right. Okay. And similar to that, we have like ACI as well. ACI EPIC controller, Application Policy Infrastructure Controller, we have as well. And that EPIC controller will be responsible to manage the ACI data center. Now, what they are planning, actually, they are planning to have like one, let's say, for example, UI. So from there, we can manage like all the things. So they have already, like, if you go to this DNA Center, in the DNA Center, they have now added the, like, you can go here, DNA Center, we can go to like, system settings. And here we can actually integrate, these external services. These things we can integrate. See, we can integrate like, for example, our vManage. Here we can add on our vManage. So vManage is basically the controller. vManage is the controller for the SD-WAN. So we can add on the vManage controller information here, so that the DNA Center can push the information to the vManage. Basically, the DNA Center will be responsible to manage the routers as well. That can be done. So they have added this option where we can manage this vManage from here itself. And we can basically integrate these things. We can also deploy nowadays the DNA Center onto the cloud. So if you have deployed the DNA Center onto the cloud, you can like actually add on that here as well. Right. So the point is that this is how the user interface looks like. This is how the user interface looks like for the SD-WAN, which looks quite similar to like, the DNA Center one, looking quite similar to the DNA Center. So this is for the vManage. This is the user interface to manage all the routers from one centralized point, let's say. So the user interface looks quite similar to this. In fact, if you open the user interface of wireless LAN controller, if you open the user interface of like ICE, Identity Services Engine, nowadays you might notice that, almost like all the things from the user interface point of view, they are taking it exactly in this fashion. And nowadays we also have this option of interactive help, from where you can get the help from like, different things. Let's say, for example, you don't know a lot of things about this DNA Center. You can always like take the help from here nowadays. You also have this interactive help option like here nowadays. So when it comes to like user interface point of view, they are now trying to basically have the similar kind of user interface. No, on the vManage, we cannot integrate the DNS. Their long-term plan is to have the DNS center as the centralized controller for everything. So DNS center is the main controller. You can consider it like that. DNS center will become the main controller to manage the things from one centralized point. Sooner or later, you will notice. No, we will need the vManage, but when it comes to the management, everything will be done from the from the DNS center itself. Because the DNS center can now integrate with the vManage, so we can push the policies and everything from here itself. And if you want to do some specific things on the branches from the router point of view, then of course we have our vManage dedicated as well. But who knows? Like maybe later on, who knows? Like maybe later on they, they do all the things from the DNS center. Who knows? But their long-term plan was to have a centralized controller to manage all the things from one central point. So DNS center is actually that controller which is going to have the centralized, which is going to be used for the centralized configuration, management, provisioning of. I would not say everything because that's not true like at the moment, but sooner or later you will notice that it will be the one which will be responsible to manage all the things from one centralized point. Right. So 3 SDN offerings are there nowadays from the Cisco. One we have here this SD-WAN. One we have here this SD-Access, and then we have here ACI Epic. Fine. All right, so now we will talk about since our content is not going to focus on this ACI Epic, content is not going to focus on the SD-WAN. We will now focus on the SD-Access. So we just talked about, now we will see how SD-Access is going to deal with all those challenges that we have just talked about. How the DNS center, how the SD-Access is going to deal with all those challenges that we have just talked about. We'll talk about that. Right, so they are again to tell you that they are actually trying to have a centralized controller that will be responsible to manage all the things from one centralized point, and sooner or later you will notice that the DNS center will be the same. So since they have already integrated, we can already integrate our vManage into the DNS center. So I don't think the only thing that is left is the ACI one, is ACI Epic. As soon as they get integrated together, it will just be a centralized controller for everything. vManage is already done. Right, and see the user interface for the ICE is quite similar to as well. They're trying to make the user interface of all these things to look quite similar, so that the user, they don't need to navigate on different. If you open the WLC interface, it will also look like exactly the same, like the similar kind of thing. Right. So now we will talk about specifically. We'll not talk about SD-WAN. We'll not talk about ICE at the moment. We'll not talk about ACI Epic. Now we will talk about specifically the DNS center, how the DNS center, how the Cisco SDA solution is going to deal with all those challenges that we have talked about so far. Security related challenges, operational related challenges, like configuration related challenges, how all those challenges are addressed by the Cisco software defined access. Okay. When it comes to Cisco software defined access, Cisco SDA is a solution built within the DNS center. DNS center, Cisco SDA is a solution within the Cisco Digital Network Architecture, or DNA. Cisco SDA is basically a part, it is just more like a small part of the Cisco DNS center, which is built on intent-based networking principle. IBN, intent-based networking, means basically where the administrator, where the user is going to give its intent to the software, and the software is going to configure it in the network. Right. So for example, here, this Cisco DNS center that we have, to this DNS center, the administrator is going to give its intent, and based on the intent of the administrator, the network is going to be configured. So Cisco SDA is a solution within the Cisco DNA Center. Like go to this option called provision, and here we get this option called SDA. Not only this, like this is specific to the SDA, we need other things for the SDA to work as well, such as we need to create the design of the network, we need to create the policy for the network, we can do the monitoring of the network, we can do quite a lot of things, but the point remains the same, that the SDA, DNS Center is not the SDA. That is the point. The point is that DNS Center is not the SDA. SDA is not the DNS Center. SD-Access is just a part of the Cisco DNS Center. SDA is just something that we get offered within the Cisco DNS Center enterprise network. Right. So Cisco DNS Center has this Cisco DNS Center is going to use this as the access to manage all these campus or local area campus LAN switches from one centralized point. We will see. We'll talk about, like, is it only for the routers or switches, only for switches or router? We'll talk about that. Don't worry. We'll see like what type of devices we can manage from the SD. But anyway, SD-Access, SDA is just a part of the Cisco DNS Center. Cisco DNS Center is a product. DNAC, DNS Center, is a product that offers us the SDA capabilities. So if you want to benefit from the SDA, you need to have this DNS Center controller installed in your network. The DNAC, DNS Center controller, must be there in your network so that you can take the benefit of the Cisco SDA. Cisco SDA provides visibility-based automated end-to-end segmentation to separate the user, devices, application traffic without redesigning the underlying network. It says that your physical network can remain as it is. Your physical network can be like 3-tier, 2-tier, whatever, it does not matter. Your physical infrastructure is going to remain as it is. Let me show you a topology. DNS Center says that your physical network infrastructure can be like as it is. You don't need to change anything. You do not need to change anything from the physical infrastructure point of view. Your physical network can be, you can design your physical network in any way, doesn't matter. So something like this, for example, here, I have built this small topology in the Cisco packet research software to, give you the idea about the SDA. So here we have like our different types of devices. Here we have devices such as, for example, some access layer devices right here. We have some distribution layer devices. We have some core devices. This is considered that one of the building. This is considered that second building. And those buildings are getting aggregated. Those buildings are getting connected basically with the help of this, core layer and these traditional concepts that we have. It says that you do not need to actually do anything on your physical network. Your physical network can remain as it is. You do not need to change your physical infrastructure in any way. So you are going to have a few switches. You are going to have a few switches that are going to act as the access layer, that are going to be connected at the access layer. Then you can connect these switches with the help of distribution layer. And in a big campus network, we can also have the core layer to, move the traffic from one building to other building, from one, point to other point. And these devices, these core layer switches, maybe are connected to some routers. This router is going to take us to the known network such as data center, other branches, and this router is going to take us to the unknown network such as internet. Okay. So this is our traditional design. They say that you do not need to change your traditional design. We have made the reachability between all the devices and all that by configuring the trunks, configuring the VLAN, all that thing. You don't need to change anything. This infrastructure that we have built will be treated as something called underlay network. And on the top of this physical infrastructure, Cisco SDA is going to build some logical network as per the user's requirement. And that logical network that will be built on the top of this underlay network is what we are going to refer to as the overlay network. So with the help of this concept called overlay, the Cisco SDA, Cisco Software Defined Access, is going to facilitate the functionalities of the software-defined networking. Cisco SDA is going to leverage the concept of underlay and overlay to provide the SDN functionalities. Right. So here you can see that Cisco SDA does not require you to redesign the underlying physical infrastructure. It can remain as it is. However, we can build some logical network on the top of this network, which we are going to refer to as overlay network. And that overlay network is going to deal with like how the data is going to be moved from one switch to another switch, from one device to another device, from one device to another device, and so on. Maybe our certain user traffic can go from here to, let's say, for example, directly here. For certain application traffic, the traffic flow can be different. For certain user traffic, the traffic flow can be different, can be same, whatever suits you. So the concept says that here, it provides the visibility-based automated end-to-end segmentation to separate the user, devices, and application traffic without redesigning the underlying infrastructure. Our underlying infrastructure will remain as it is. And what I'm going to do, I'm going to create a different VN, virtual network, which is equal to VRF. For our IoT devices, I am going to create a different VN for a VN equal to VRF. For our maybe guest users, I am going to create a different VN, which means basically like a VRF for our corporate users maybe. And we can have a different set of policies for the corporate user, for the guest user, for the IoT user, all being managed from the DNS center itself. Yes. Underlay basically means the underlying physical infrastructure on the top of which a logical network called overlay will be built. You can compare this underlay overlay concept with your traditional network DM VPN, for example. In the DM VPN, what happens? Let's say these are two routers, and this is like one LAN network. This is one LAN network, and it is connected via this transport such as internet. So this device, this cable, this default route, it all is going to be part of the underlay network. And when we do the configurations of the tunnel, a logical tunnel is built from one device to other device, from one device to other device, that is going to carry the LAN traffic. Right. So exactly similar concept you can consider here as well in the SDA underlay and overlay. Underlay is the underlying infrastructure on the top of which the overlay network is going to be built. Underlay is the underlying infrastructure built using router, switches, cables, protocols, and all that. And then on the top of that, a logical network is built, which is referred to as the overlay. A different protocol will be used to build the underlay network, and a different protocol will be used to build the overlay network. Right. So overlay and underlay, they are going to leverage the concept of different protocols to keep or to make the SDN, to make this software-defined access network function. Overlays like GRE, DM VPN, these are much more common terms, like as compared to VXLAN. Like GRE, DM VPN, you can configure the IPsec maybe, the tunnel end-to-end tunnel maybe. So that is more like the overlay example. And the underlay example is your traditional router switches connected together, made reachable with the help of some protocols. Right now. Okay. So Cisco SDA, Cisco Software Defined Access, is going to it automates the user access policy, so the organizations can make sure that the right policies are established for any user or device with any application across the network. This is done by applying unified policies across the LAN and wireless LAN. So the administrators, they don't need to worry about configuring different policies for the LAN and the WAN user. They can have same policy, and the same policy will be applied for the LAN, same policy will be applied for the wireless local area network. Means the user gets connected to the network, user gets connected to the network, user gets connected to the network, no matter if the user is connected via, no matter if the user is connected via wired or wireless network, same policy will be applied. Same policy will be applied for that particular user, right? And all of these things, like, creating the network, creating the policies, everything is done on this graphical user interface itself, onto this GUI. Everything is done from here. See, build your underlay network, make sure that all the devices, switches, all the devices are reachable to all the devices. Make sure that all the devices are reachable to the DNA center. And from DNA center, now we can build our overlay network itself. There are workflows, there are these options, these tabs that we can explore to build our overlay network right from here. We can design our network, we can create the policies for the network, we can provision the devices in the network. Provisioning means like configuring the network with some, roles and other things. And then monitoring we can do from the net, from here itself. So these are 4 workflow. The DNA center offers 4 workflows to manage your entire network from one centralized point. One is called design workflow, one is called policy workflow, one is called provision workflow, and one is called assurance workflow. Using these workflows, we can do everything from A to Z, everything. Like, just make sure that the devices are reachable to the DNA center, and rest you can do from here itself. Yes, IP reachability is required. Yes. IP, other things are required as well. IP reachability, user ID, password, credentials, SNMP, a few things are required. But the point is that DNA center should be able to reach and log into the device. Let me rephrase it. The DNA center should be able to reach and log into the device so that it can, push the necessary configuration to those devices. Reachability is one factor. Second thing is that the DNA center should be able to reach to those devices. Log into those devices. Everything will be done when it comes to creating the overlay network. We will use the GUI to create the overlay network. CLI we will use. I'm not saying that we are not going to use CLI. We will be using CLI, but CLI we will be using to configure the more like the underlay network. Like, we will not be using the CLI to configure the overlay network. That will be done by the GUI. Building this next generation SDA solution involves some key foundation elements such as controller-based architecture, okay, DNA center, policy enforcement engine, okay, ICE, identity services engine, network fabric, okay, underlay, overlay, programmable interface, okay, API. We have all the components that we use to build this overlay network, such as we have our controller, we have our policy enforcement engine, we have our concept of underlay, overlay, and we have the concept of APIs, not APIs, application policy, application programming interfaces, by which we can use third-party automation tools to manage the DNA center as well. PNP can be used here as well. Like, even if you don't want to build the underlay network by yourself, we can use the PNP plug and play. PNP can be used to automate in an automated fashion. PNP can be used. PNP can be used actually to automatically onboard a device into the fabric as well.
I just want to ask one question.
Yeah.
That you have right now said plug and play. So simply we have to power on that device and DNet will automatically log into that switch
Yes, possible.
without any configuration.
Yes, that is possible.
How DNAC will know the IP address? What type of
Yes.
configuration is being done?
That I will show you practically in the lab.
Okay.
That is possible. Nowadays, devices come with this, option of PNP, completely possible. Just to PNP, ZTP, just to give you the idea, just to give you a hint on all these devices that are capable to be onboarded via PNP, plug and play, ZTP, whatever you say, zero touch provisioning, plug and play, whatever you say. So what happens, like all these devices have a PNP agent, installed. And that PNP agent, like when the device boots up, it is responsible to discover the controller, not only the DNAC, whatever. The PNP server, it is responsible to discover the controller. It will reach out to that controller, it will reach out to there, and it will pull the configurations from there and all those things accordingly. So that I will show you practically in our lab. What we will do, we will onboard a WLC using the PNP. I will not set a single thing on the WLC. I will show you, like using the PNP process. I will show you how to, add a WLC in the lab. It takes some time, but it's a very good concept actually. Okay. Now, how the DNS center. So Cisco software-defined access design, when it comes from the design point of view, what components it will include, what your SDA design is going to include: routers and switches, AP and WLC, identity service engine, and DNS center. These are the components that you will require. Again, like hardware, software can be hardware, software, hardware can be hardware. Like we require hardware, for the purpose, for this purpose. We require like a lot of hardware for this SDA lab and SDA deployment point of view. Why we cannot do things on the software, that we'll also discuss later on. Now, when it comes to making the reachability between the devices, we can use any IGP. However, Cisco says use ISIS. We can use any IGP. We will use both actually. First of all, we will build our network using OSPF, and then later on we will build using the ISIS. So we can use like any IGP. We can use any IGP to make the reachability between the devices. However, Cisco recommends that you go for ISIS protocol. Right. So once we have made the reachability, then the tunnels will be built from the device to device, and those tunnels are built with the help of a protocol called VXLAN. VXLAN is a protocol that will be used to carry the data traffic from one S device to other S device, from one device to other device, from one switch to other switch. The traffic, from one switch to other switch, the traffic can be carried. Traffic will be carried using a protocol called VXLAN. And Lisp, when it comes to like Lisp stands for Locator ID Separation Protocol. Lisp is used as the control plane protocol when it comes to the SDA. Like, how this device will know that if I want to reach to this subnet, this is where I have to go. The routes and everything, that is basically Lisp. Lisp stands for Locator ID Separation Protocol. Lisp is a protocol that is used as at the control plane in the SDA deployment. VXLAN is the protocol that is used as the data plane in the SDA deployment. And the CTF, Cisco TrustSec, is used in the policy plane of the SDA deployment. We'll talk about like VXLAN a little bit. We'll talk about Lisp a little bit. We'll from the terminology working point of view, and we'll talk about Cisco TrustSec based on ICE a little bit. Okay. So from the components point of view, from the hardware components point of view, these are the things required. From basically the architectural point of view, these are the components required, and these are the protocols required to make the Cisco SDA work. And router, you cannot just choose any random router or switch. The routers and switches that you are going to use in your SDA, they have to be compatible. They have to be from the compatibility list. They have to be compatible. If these are not compatible, then then you will not be able to, deploy it in the network. ICE can be both as a hardware or a software. We can purchase a server called SNS, Secure Network Server, and that can be used as a hardware for deploying the ICE, or we can deploy this in a VMware environment as well, virtualized environment. No, policy basically means like policy plane basically means like from where we configure the policies such as scalable groups. We can configure the ACL based policy, but what we are going to do, we are going to configure the policy based on those scalable groups like that is there in the ICE actually. Now, how this DNS center, how this SDA deployment is going to ease the challenges that we were talking about earlier. Okay. So first of all, like what challenges we have talked about? We have talked about that there are a lot of challenges in the traditional network. There are a lot of challenges that we face regarding like deployment, regarding like operations, regarding like different things. So first of all, let's see like how these challenges are going to be addressed. Like let's talk about these one by one. So first of all, we talked about that all these devices that we have in a modern day network, they have their own set of control plane, management plane, data plane, control plane, management plane, data plane, control plane, management plane, data plane. So if we want to manage all these devices, we will need to take the access of these devices one by one. We need to take these access of all these devices one by one and do the configuration, which is not the case with the DNS center. Why? Because our Cisco DNS center, this DNS center hardware appliance that we have can be used to manage all these devices from one centralized point. A DNS center can manage a lot of devices. For example, this DNS center, as you can see here, currently is managing total 121 devices that are scattered around the world in different geographical locations. You click on this device tab, it will list you all the devices that it is actually managing. All the devices that it is basically managing. So for example, like you can focus specifically on the routers. These are all the routers that it is managing. This is like, these are the switches. Like these are the switches that are added in the DNS center. These are the wireless LAN controllers, for example, that are being managed from this DNS center. These are the APs. These are different sensors. Like if you click on all, this is a list of all the routers and switches, all those things that are being managed by this Cisco DNS center. And you can see, let me show you. You can click on any device. Let's say, for example, I can click on, let's say, for example, this switch. I click on this switch. And I can see like this switch is actually deployed in this location. Like this switch is deployed in the San Jose location in California, in USA, in America. This is deployed in this particular location. And here I can click on this button, and right from here we can execute a few commands. Not all the commands are supported. These are the commands supported. These are the commands that are supported. We can run some basic commands from here, ping test and all those things we can do from here. And we can also, let's say, for example, we can, check the device information in detail. If I click on this button, it will open a new tab, and here we can check the information in detail. We can click on this button and it will open the information in new tab. So we can actually, log in and we can check the information about the device in very detail right from here. No need to, log into the device and get all that information. No, you don't need to do that. Just click on the device, just click on this button. It will open a new tab, and there you will get the information of the device in very much detail. Everything about that device, almost everything that a SNMP monitoring, almost everything that a typical monitoring tool can give you the information. All that information you can get on here just with this single click. We can click on show more button, so it will give me more information. about that particular device, such as, for example, what type of device it is it supported for the SDA or not, the the IP address and all that information we can get. Right, so it gives you like we might not have privileges to check all that information, but we will see that later on. The point is that we can see that this DNS center is able to manage like multiple devices at the same time. A lot of devices are being managed right from here. We do not need to actually manage all the devices one by one. So if every device has its own management plane, but we can manage all the devices from one centralized point as well. Not only management, we can also do the configurations on these devices regarding the SDA right from here itself. Right from here itself, we can do the configuration on the devices as well. We can push the configuration changes from the devices from here itself. We can configure the policies right from here itself. We can configure the policies and we can push those policies onto the devices right from here itself. So we will not be needing, to access all these devices one by one. We can just deploy the DNS center and we can actually configure all those things from one centralized point. We have devices that are capable to be managed. We have nowadays devices that we can manage from one centralized point. Okay, fine. So second, we had like security related challenges. When it comes to the security related, in the traditional network, security was enforced with the help of ACL, with the help of VLAN and all those things. In a Cisco SDA network, like we need to configure multiple VLANs, we need to configure multiple ACLs and all that to enforce the security, which might be a little bit time consuming process, which might be difficult to T-shoot and all. Here, however, we don't need to do that, because in a Cisco SDA environment, the security is enforced with the help of something called ICE, Identity Services Engine. Security can be enforced in the format of or with the help of actually these scalable groups. Group-based access control. Group-based access control is there. Group-based access control, like we can define the policies from one centralized point. All the policies and everything we can define actually from one centralized point. No need to go on all these devices one by one and configure a different policy for wired user, different policy for the wireless user. No need to log into the WLC, configure a policy there. Like we can define the policy based on the user instead of based on like wired or wireless network. So we have a dedicated tab in our Cisco DNS center, and from that tab actually we can configure everything regarding the policy. So all the security related challenges that we were facing regarding the ACL because of the ACL VLAN, all those things, like we can address from here. We can go to the policy tab, and right from here we can create the policies based on our requirement. We can create the policy based on like IP, URL. We can create the policies for the applications. We can create the policies for copying the traffic span. Basically, everything can be done right from here itself. Security can be managed from here itself. We can manage different things regarding security right from here. We can create our access contract. Access contract basically means like who can communicate with whom, like what can communicate with what. That contract we can create. We can create our security groups, which are also referred to as SGT tags. And then we can create the policy. This is policy metrics. This is the policy metrics. And from here, we can actually configure our policy as per our requirement. As you can see, there are total 106 policies configured at the moment. Like, for example, bring your own devices cannot communicate with auditors. Bring your own devices can communicate with the auditors in SDA. Bring your own devices. To bring your own devices, inspection will happen. So some policies we can configure right from here itself. No need to go on all these devices one by one and configure the policy. We can configure like all the policy related things from here itself. How that thing will happen and all, we'll discuss that later on. Don't worry about it, but everything can be managed from here itself. We can create the security groups, we can create the profiles, we can integrate things such as stealth watch, we can integrate like a lot of other external services as well, we can also integrate. So security related things can be addressed right from here itself. We can manage both wired and wireless network right from here. You can see that this is not only telling you the information that it is managing 121 devices. These all are not like wired, like routers, switches. These are also like wired and wireless. Both the devices can be managed right from here. Both the devices like wired, wireless, both the device, like all the types of devices can be managed right from here. Routers, switches, the access points, AP, the access points, the WLC, all these devices can be managed right from here. See, this is the information that we get. This is the information that we get actually. You can get like quite a lot of information right here. If you click on this button, View 360, you will get like a lot of information from here. So we can manage all the management related challenges that we were facing. The management of the devices, of the wired devices and the wireless devices can be done from this single point itself. From the same point, we can manage all the wired and wireless devices. No need to, log into different devices to do the same. We can leverage the process. We can leverage the process of PNP and ZTP, plug and play and zero touch provisioning, to deploy the device in a complete automated fashion. We can leverage the PNP or ZTP process, plug and play or ZTP process, to deploy all the devices in a complete automated fashion. We will not need to configure all those devices one by one. ZTP and PNP actually allows you to do minimum to no configuration onto the device, and the device gets onboarded onto the network. This is the cloud DNA, like they have 121 devices being managed from here. They are just for demo purpose. Right? So all the challenges that we were facing in the deployment basically means when we need to deploy a device, we need to configure some, commands on there and all that. We can use the processes such as PNP and ZTP so that a device can be onboarded in a complete automated fashion. You go here, you go to the provision, you go to the plug and play, and here we'll see that practically later on. Here we can see a lot of devices. A lot of devices are basically just being managed automatically, like they are being onboarded onto the fabric. PNP, plug and play services can be used to automatically onboard the devices into the SDA fabric with minimum to no human intervention, which is going to ease the deployment of the devices into the new branches. Deployment related challenges can be addressed here. Okay, now the best thing. Let's say when it comes to operational challenges, your network is completely up and running and you want to get some insights of your network. DHCP we are not going to configure on the device. So on the device, we will not configure anything and still the device will be onboarded into the network. We will see how that happens. So let's say everything was working fine, and then you wanted to get some more insights of the network. So here we have the option of assurance. And from the assurance option, we can actually monitor the entire network right from the same dashboard. It is as good as this assurance option is as good as your, those monitoring tools that you use. We can get the overall network information. We can get the network information. We can get the client information. We can get the application health. These are the health dashboard, client health dashboard, network health dashboard, everything we can check on here. Different services that are running in your network, how healthy those services are. How many wireless clients are there? How many wired clients are there? Everything you can manage, everything you can check from here itself, the health of all those devices. Click on the client, scroll down, and these are all the clients that are connected actually. I can click on any client, such as, for example, I clicked on this client, and I can check in 360, I can check every information about that client right from here. How it is connected, see how the client detail, the Android, OS, Mac, IP, and all that information, how it got connected. This is the device. This is basically the AP. This is this is the radio frequency using which it is connecting. This is the AP. This is the WLC. So this is how the onboarding has happened. We can also, for example, if this device reports any issue, we can see the issues right here. That issues can be seen right here. We can check different events that have happened. All the events that have happened can be seen here as well. We can click on it, and it will expand that event, what happened at what time. It will you can get that information in detail. From the device, I can do the ping and trace itself. From this device itself, I can do the ping and trace so that I know okay, how the traffic, if the traffic can go, if the traffic cannot go from one point to that point. So we can run a path trace, we can run the trace and everything from the device itself as well. Okay, for example, if I want to reach to 8.8.8, let's see if the device is reachable to 8.8.8 or not. Right, so you can click on start button and it will show you so the traffic arrived on this AP, from AP it went to the WLC, from WLC it went to the next device, then next device, and then here the ACL inspection was done, and then the packet was sent or dropped. It will be shown to you. There is an ACL applied, I think, on there, and that is basically blocking the communication. Yeah, so see, result says that ACL result says deny. Basically everything, you can check the path trace, and this is the path trace analysis tool. You can scroll down, you can check the application experience for different applications that it is running. So DNS application experience, SNMP application experience. Basically everything you can check from here. It is as good as your monitoring tools that we use. You can get the information about the network in very much detail. You can get the information about the services that you are running, applications that you are running in very detail. You can get the overall network information. We'll talk about the assurance dashboard later on, but you can get all the information here. And let's say some issues have been reported. Let's say this is a priority 1 issue. Some issue has been reported, right? Issue has been reported that layer 2 loop symptoms. You can click on this issue. It's in this region, issue has been reported that host flapping has been observed in VLAN 1. Right, so you click on this. You can not only get the details, of the issue and everything. You can see that these are the logs that are coming onto that device. So this is the problem. This is the problem. Not only the problem, it says that a potential loop details, potential loop conditions are there. Not only the problem, we can click on this root cause analysis. We can run this machine learning, AI, artificial intelligence, machine learning capabilities of this device. And it is going to analyze the entire network at that location. And it will give you the result. It will give you a probable solution for that problem as well. Not the reactive, action, but you can see that what was the problem. As per the root cause analysis, there is a loop on VLAN number 31. And what could be the solution? It also gives you the suggested actions and all as well. that enable VLAN 31 instances on these devices, and then like your looping problem will be gone. So not only it gives you the idea about the problem that you are facing, but it can also suggest a possible action that you can take to overcome that challenge. So which is going to, quite like it is going to minimize like a lot of operational challenges that we were facing. Right, we can not only do the configurations from this device to other device, like from this DNS center to the devices, but we can also, in fact, manage. We can troubleshoot the network from here as well. So those challenges that we were dealing, like how we can deploy any device in a complete automated fashion, like with minimum to no user intervention, we can manage the devices from one point, we can do the troubleshooting, we can discover the devices right from here, discovery tool. We can have the topology tool, which gives you the idea of the entire topology worldwide. Like this is the global topology. Like this tool gives you the idea about the entire topology, like the entire topology all around the world. Right. And you can also take a look at the topology like here. In the particular geolocations, you can also take a look at the topologies that are there in the specific location. What type of topology you have, you can check it on there as well. Right, San Jose location on different. This is called topology tool. Yes, same like MI like machine reasoning. It uses machine reasoning actually. It uses machine reasoning to get the idea about like what is going wrong, what exactly is wrong, and get the symptoms. Like this could be a possible reason for the problem that you are facing, and it is going to suggest you the action based on the same. Artificial intelligence, machine learning. We can say that, yes, we can say that it is using that to give you the idea about the problem and its a possible solution as well. So it is going to like solve like a lot of challenges, a lot of issues that we have in a traditional network. And since it can be integrated with other tools as well, such as vManage, such as other third-party automation tools, so it will be easy, like for those tools to interact with this DNS center, and DNS center be the centralized point from where you will be able to manage all the things. Okay. Now, so the use case, building on the foundation of industry-leading capabilities, Cisco SDA can now deliver key business-driven use cases that realize the promise of a digital enterprise while reducing the total cost of ownership. So increase visibility, determine, create, apply, monitor network policies, zero trust security, user mobility, guest access, IoT integration, monitoring, troubleshooting, cloud, data center, branch integration. Everything can be done on this SD-Access. We will get the increased visibility of the entire network worldwide. We can determine the type of traffic flowing from one particular branch, and we can create and apply the policies for that particular branch. We can monitor the network traffic of that particular branch. We can implement zero trust security for the workplace. That means like no one is trusted until they get authenticated. So every device needs to be authenticated first. Once they get authenticated, then only they are going to be allowed to join the network. Let's say, for example, since we are going to use like wired and wireless, both the type of network, users can roam from one point to other point without being bounded to the wired network 24/7. They can just connect themselves to the wireless network. They can move from one building to another building. They can move from like a floor to another floor, and their network will not be disconnected. We have the user mobility. User mobility basically means that the user can move from one point to other point. User can move like one point to other point without any problem. We can have separate policies for the guest users. Like, for example, when the guest user arrives, like it is just allowed to communicate with the internet, nothing else. It is not allowed to communicate with the corporate users, corporate database, or some other users for the same. So the point is guest access. Guest access can be, provision guest access can be given to the devices. Guest access can be given to the users respectively. We can integrate now IoT devices, like we can have a different set of policies for the devices. We can have a different set of policies for like IoT based devices, different types of sensors we can deploy. Those sensors can actually, give you the idea about the different things as well. We can monitor and troubleshoot the entire network from one centralized point, again, from one GUI, from one graphical user interface. We will be able to, monitor and troubleshoot the entire network. And we can integrate like data center, branch, cloud. Like we can integrate it with anywhere, like anywhere where we have switches, routers, like, those devices, we can have it integrated everywhere. So enhance endpoint visibility by using advanced analytics for the users and device identification and profiling. We can employ artificial intelligence and machine learning technique to classify similar endpoints into logical group. Like the policy, this is basically talking about policy. Like when we talk about creating the policy, instead of configuring the policy based on the IP address, what we can do, we can group similar type of users, such as IoT devices, such as routers, such as switches. We can group similar type of user, and we can group similar type of user and create the policy for that entire group. We can define, we can classify similar endpoints into logical group, and then we can define effective policy with the help of these, groups that we have just created. So all the traffic that flows from one point to other point, for the traffic, we can have a common, a unified policy for our wired and wireless user. We can enforce this policy through the network infrastructure using simple and intuitive graphical interface. We can create the overlay network, create a virtual overlay network to segment both wired and wireless network uniformly and separate the unrelated traffic to provide just the right level of access to the endpoint, boosting the compliance and reduce the business risk. Not everyone is going to communicate with everyone. Only the devices that are allowed to communicate with other devices can actually. So we can create like a logical network. We can create the logical network. We can create the overlay network. You can create these overlay network. We can create these logical overlay network on the top of the underlay network. And in this overlay network, we can define the rules as per our requirement. We can create the virtual overlays. We can segment our wired traffic with the wireless traffic. And we can also separate the unrelated traffic to provide right level of access to the endpoint, boosting the compliance and reducing the business risk. Exchange operating policies and ensure consistency by utilizing Cisco intent-based networking. Multi-domain architecture for enforcement of the policies through like LAN, WAN, and multi-cloud data center network. In short, basically, from day 0 to day 2, almost like all the things can be done from one centralized point. We can, we can onboard the device without like doing any configuration on the device itself. We can onboard the device. We can onboard the device with the help of processes such as ZTP or PNP. Here we are going to use the PNP, not the ZTP. PNP. So we can use the PNP process to actually onboard. We can use the PNP process to actually onboard the devices in a complete automated fashion. No need to actually, do the configurations on the devices all by ourselves. And then we can create the policies for those devices. We can have, we can group those devices into a, separate set of devices. Like we can group, a set of devices can be grouped together so that we can apply the policies for those set of devices different than the other ones. So all those things can be done like from one centralized point, like right from here, the DNS Center graphical user interface, we will be able to do all those things from one. So it will save approximately, as per the, again, research, as per the research, it will save approximately like 67% like saving in the network provisioning time, 80% less time in issue resolution, because it uses that artificial intelligence and machine learning process to automatically give you the idea about the issue and its possible resolution. Return of investment, 5-year return of investment is approximately like 462% as per their documentation. The 48% reduction in the impact of the security breaches, 45% of reduction of cost of operation, 49% more efficient network management staff. All these things we get from the Cisco software-defined access. We can remotely access the devices from the DNS center as well. However, the level of control is going to be very limited. We will see later on when we onboard at least one device, we will see how much control we have when it comes to like remotely accessing the devices from the DNS center itself. And one more thing, you do not need to remove everything from the scratch. If your devices are compatible in your existing network itself, you can integrate this Cisco SDA. We can take the benefit of like, macro segmentation, micro segmentation, and all those things. Basically, we can integrate. We'll talk about all these things later on. We can integrate our Cisco SDA solution in the existing network, or we can have it deployed for the fresh network as well. With minimum disruption to their users and connected devices, it is possible to actually migrate from the traditional network to the SDA network. If your devices are compatible with the Cisco SDA solution, you can upgrade the operating system. You can have a DNS center appliance in your infrastructure, and you can do the things from there as well. Organizations wishing to convert their existing network to simplicity, automation, and security that SDA offers, they can do with minimum disruption to their users and connected devices. You can deploy like a branch maybe completely on the SDA, complete like new branch has been deployed in the SDA, or we can upgrade the existing branch into the SDA as well. We get like full SDA access for our new network or for our existing networks. It's not going to be that simple. Like migration is not that simple, but it is possible without disrupting the services and the connected devices. We can migrate from the traditional to the SDA network, but the process is not exactly the simple. You can add whatever switches are compatible with the DNS center. You can add those switches in whatever fashion you want to add. You can add whatever topology you want to create. You can have whatever type of topology. The main point is that the switches that you are going to use must be compatible with the DNS center. DNS center will be able to manage only those devices that are compatible with it. So if the devices are compatible, like if the switches that you are trying to manage are compatible, no matter in what fashion you are going to connect, it's okay. If you're worrying about the looping problem and all those things, it's not going to be there. So overall, Cisco software-defined access gives us deep visibility where we can identify and group the endpoints. We can map their interaction and define the policies based on the same. We can identify and group the similar type of endpoints into a logical group, and then we can create the policies for that group. So we get a better visibility of the entire network. We can create the policies based on the group rather than creating the policies based on IP. So group-based policy and segmentation can be done. Enforce the group-based access control policy, secure the network for segmentation, and the policy will remain consistent. Like you can have the same set of policy for wired, wireless user, it does not matter. From the architectural point of view, we will require the devices. We will require the controllers. Controllers Cisco DNS Center is going to use like 4 workflows. The policy workflow, design, there is something called design workflow, policy workflow, assurance workflow, and the provision workflow. And from there, we will be able to design the network. We will be able to create the policies. We'll be able to provision the devices, and we will be able to monitor the devices from anywhere. As long as you have the access to the DNS Center GUI, you will be able to manage all the devices from one point. Right? Devices have to be compatible. That is one thing you need to make sure, which will be covered actually in the class of like physical layer. When we talk about the physical layer, we'll talk about like what devices are compatible with the DNS Center. Right. So from the architectural point of view, like we require these things. So Cisco SDA is an enterprise networking solution based on intent. An intent-based network views the network as a single system that translates and validates the business goals into the network and returns actionable insights. When it comes to like components of the SDA, Cisco Campus Fabric composition of underlay overlay and the DNS center. So Cisco SDA is basically campus fabric with the DNS center. Campus fabric, Cisco campus fabric is the underlying infrastructure on the top of which a logical network is built, which is what we refer to as the overlay network. And then the DNS center is the centralized controller that is responsible to manage all these devices from one point, create the policy and other things, which is central to all these devices. A traditional physical network connecting the LAN devices, such as the router switches, is known as the underlay network. And an overlay network is referred to as a fabric and is a logical topology that is placed on the top of topology independent physical underlay network. So on the top of the underlay network, a logical network that will be built, and that will be referred to as the overlay network. So this is all the basics that we need to know from the SDA point of view. All these things are in your book as well, the book that we have just discussed. You can refer to that book for the study purpose. We have already talked about that. So this slide will be uploaded onto the portal as well, and you can refer to that PDF that we have talked about for better or in detail understanding of this. So in short, like Cisco DNS Center is a hardware that you need to purchase and install. And within this Cisco DNS Center soft hardware, we have this option called SDA. SDA is used to manage the campus area network in an automated fashion. Right, so this is all that we need to know from the basics of the SDA point of view. Now we will talk about from the architectural point of view, from the architectural point of view, what are the devices and all those things, like what devices are compatible and all that. We'll talk about that. We can design a 2-tier architecture, 3-tier architecture. In a data center, we can have that ACI, application-centric infrastructure and all that. So if you have like a lot of switches, like if you have 3-4 switches in one of the branch, and similar like you have 3-4 switches in other branch, and you have quite a lot of branches all around the world, managing all those switches from one centralized point, if you can achieve that, if you can manage all the switches from one centralized point, it will ease the configuration and management related challenges that you might face in a traditional network. So this Cisco software defined access aims towards exactly the same thing. Cisco software defined access, Cisco SDA, tries to simplify the network configuration and provisioning from one centralized point with the help of a controller called DNS Center, also nowadays called Catalyst Center. So DNS Center or Catalyst Center that we have, DNS Center or the Catalyst Center that we have here. DNS Center and the Catalyst Center, that Catalyst Center is like the term that we use nowadays. The DNS Center that we have is the term we used to use in a Catalyst Center, they have branded, repurposed those things like. Now, when we talk about so when it comes to DNA fabric, when it comes to SDA network, we have DNS Center at the core of the network. Then we have this campus fabric. Campus fabric is basically going to be the combination of this underlay, overlay, that network. So we have that. We have then that the DNS Center we have campus fabric. And combination of both is what we are going to refer to this as the SDA. SDA is basically, SDA allows us to have Cisco software defined access. Cisco SDA allows us to have from one centralized point manage and configure all the devices. Okay, fine. Now from the DNS Center is a hardware. As you guys might have guessed, DNS Center is basically a hardware, and that hardware is going to actually, you have to purchase that hardware. Once you have purchased that hardware, you are going to actually install that hardware in your location, and you will make all the reachability and everything. You are going to make all the reachability and everything. Once you have made the reachability, the DNS Center is responsible to do all the configuration provisioning and everything from one centralized point. Fine. Now, from the architectural point of view, when we design the SDA network, from the architectural point of view, we have some layers in our Cisco SDA. Those layers are like, those layers include physical layer, network layer, controller layer, management layer. There are like 4 layers that we have in Cisco SDA architecture. So from the architectural point of view, Cisco SDA network can be divided into 4 layers. Like one, we have like physical layer, network layer, controller layer, and then we have management layer. Each layer has a set of devices and or protocols rules. Like for example, physical layer is going to have a set of devices. Network layer is going to have some protocols. Physical layer is also going to have some rules and everything. Right, so physical layer, network layer, controller layer, management layer, all these layers are going to have some certain set of devices to build the network, and the protocols and rules that we define onto those particular devices. So each layer has a set of devices and or protocols, rules. For example, physical layer has physical devices and rules that we set on those devices. Network layer deals with the underlay overlay. Controller layer, in the controller layer, we have the controllers that are used in our SDA network, such as DNS Center, IEs, WLC. And the management layer is responsible to deal with like how we are going to manage the network using like, are we going to use GUI or are we going to use API? Okay. So from the design point of view, we have physical layer, network layer, controller layer, and the management layer. First layer that we have here is the physical layer. The physical layer, as the name suggests, includes the devices that we are going to use in our SDA deployment. It is going to include the devices that we are going to use to build our SDA network. Okay, fine. So as the name suggests, physical layer consists of physical devices that are used to build the SDA network. Right, so we are going to have some hardware switches. We are going to have some access point. We are going to have some wireless LAN controller. We are going to have some cables, everything. Like, all those hardware devices that are needed to build the network, to build the physical infrastructure, those are going to come under the physical layer. So physical layer consists of the physical devices that are used to build the SDA network. And once we have devices connected all together, we are going to assign the roles onto those devices as well. That your responsibility is to do this, your responsibility is to do this, your responsibility is to do this. We are going to set the roles onto those devices as well. Fine. So we have different devices and different roles onto those devices. And devices will behave based on the role that is assigned onto those devices. For example, we have roles such as called edge node, control node, border node. Based on the roles that we have set on the devices, they are going to behave in the network. 4 roles are there: fabric edge node, control plane node, border node, and fabric enabled wireless LAN controller. Majorly, there are 3 rules. This fabric enabled WLC is only applicable for wireless LAN controller. But apart from that, we have like 3 roles that we can set onto these devices. So we are going to purchase some devices now. We are going to purchase some hardware devices, such as routers, such as switches, such as AP, such as WLC, and all of those devices must be compatible with the Cisco SDA. We cannot just use any random device to build our Cisco SDA network. The devices that we are going to use must be from the compatibility matrix. They must be compatible to be added in the SDA network. If they are not compatible, it will just not work. They have to be compatible. So what devices we use at the physical layer? First, let's talk about the devices, then we will talk about the role. So what devices we use? What devices are we going to use at the physical layer? What devices are we going to use at the physical layer to build our SDA network? Okay, fine. So devices that are going to be used in our SDA network, it has to be from the compatibility list. Why? Because all these devices that are compatible with the SDA, they have a chip. They have a hardware chip installed in that. They have a specific application, a specific integrated circuit installed in that, which enables the devices to run functions such as VXLAN, such as Lisp, and all those things. This specific chip, this specific application is specific integrated circuit has those properties that allows the device to participate in the SDA fabric. So the devices that we are going to use in our SDA network has to be from the compatibility matrix. If the devices are not from the compatibility matrix, then those devices are not allowed to participate in the network. Fine. This chip that we have here, is called UADP, Unified Access Data Plane. This chip that we have here is what we call UADP, Unified Access Data Plane. It is a hardware chip that is present on every device that is compatible with SDA. So if your device is not having the UADP chip, you actually your device will not be able to participate in the SDA network. So if you search, for example, UADP, you will find this UADP right here. You can click on this. You can click on this, and you can see that what exactly is the UADP. So UADP, the homegrown application is specific integrated circuit. The homegrown chip of Cisco called Unified Access Data Plane has been fundamental in driving multiple enterprise switches product. It's a better hardware performance and increased software flexibility compared to previous generations. Okay, whatever. So some older version of the Catalyst switches, also come with the UADP chip, such as 3850, right? And 3850, 3650, they had like this UADP chip, right? And nowadays, like Catalyst 9K series platforms, they come with this updated version of the UADP. So earlier version of the switches, such as Catalyst 3650, 3850, they also used to come with this UADP, Unified Access Data Plane chip. And nowadays, like we have the updated version of UADP as well, coming on this Catalyst 9000 series platform. So multiple versions of the UADP, such as UADP version 1.0, 1.1, 2.0, and now we are up to version 3.0. Functions, different functions are there. You can check the bandwidth codes and everything on that particular switch platform. So Catalyst 3850 series switch platform, it used to come with a UADP version 1.0. Then Catalyst 3850 multi-gigabit switch comes with the UADP version 1.1. Then 2.0 comes this Catalyst 9200 series switch platform comes with UADP version 2.0 mini. Then Catalyst 9300, like this is basically the Catalyst switch platforms that come with different version of the UADP. So UADP 2.0 mini, 2.0, 2.0 XL, 3.0, these are like, these are the those application specific integrated circuits that you might see nowadays in your Catalyst 9K series platform. So a hardware chip has to be present. this hardware chip is going to allow, it is going to allow things such as VXLAN routing, group-based policy option, generic protocol encapsulation, streaming telemetry, MACsec encryption. These functions are allowed because of that particular UADP chip. So if your device does not have a UADP unified access data plane chip, you will notice that your device will not be considered compatible with this Cisco SDA deployment. Okay, fine. So first thing first, we will purchase the switches that have that UADP chip, first of all. Second, if we already have the switches in our home platform, like if we already have some switches in our company network, we will find out that if those switches have the UADP installed in them or not. Because if the switches that you have in your existing infrastructure, they have that UADP chip, it is easy to migrate from the traditional to the SDA rather than purchasing new devices on there. So go to the data sheet of the switch that you have in your production environment and find out what version of the UADP that switch is running. If that switch is not running any version of the UADP, your device is not compatible with the DNA. That's it. Because things such as VXLAN and all those things are programmed into that UADP, and if those switch is not having that, your device will lack the VXLAN and all those functionalities, advanced functionalities that are supported by the SDA. As a result, it will not be allowed to participate in the fabric. Some functionality can still be managed by the DNA center. We can still manage some things from the DNA center, such as some basic things we can still manage from the DNA center. Some basic device management can still be done from the DNA center, but the device will not be allowed to join the fabric. That is the point. Okay. So here, devices to be used in the SDA network has to be from the compatibility list. They need a specific circuit, a specific application, a specific integrated circuit, so that we can define the roles onto those devices and they participate in the SDA fabric based on the role. Devices need that UADP chip hardware present into the device to support the SDA deployment. Modern day switches come with that UADP chip, but some old platforms such as 3650, 3850 also have that UADP chip, so they are compatible in the SDA fabric for certain roles. They are programmable. These chips are programmable, so Cisco can push firmware upgrades onto these switches to support additional functionality like VXLAN. Earlier days switches such as 3650, 3850, they don't used to support VXLAN, but then Cisco pushed a firmware upgrade. So you can now update your switch firmware, 3850, 3650 switch firmware, and it will now support the VXLAN functionality nowadays. Right. So modern day SDA network, in modern day switches, we already have that UADP chip. In modern day network, we already have that UADP chip. But if this UADP chip that we are talking about is not present on your device, it will just not be allowed to participate in the fabric. So nowadays, in a modern day network, when we need to purchase new switches, what we are going to do, we are mostly going to purchase the Catalyst 9000 series switches. Nowadays, campus network design is built around this Catalyst 9000 series switches. Modern day network is all about this Catalyst 9000 series switches. And this Catalyst 9000 series switches that we have in a modern day network, they come with the updated version of the UADP chip. They come with this updated version of the UADP, Unified Access Data Plane, UADP chip. And this updated version of the UADP chip that we have here, it is going to actually come with the functionality of the VXLAN and all those things that are necessary to build the SDA network. And all these switches that we have, they come with the iOS XC. They come with the iOS XC actually. We don't run iOS onto these switches. We run this thing called iOS XE. iOS XE is the version of the operating system that runs on base Linux-based core. So in a modern day SDA network, typically in a greenfield deployment, basically means the fresh deployment, we use Catalyst 9K series switch platform. They have the updated version of the UDP and they run iOS XE. What is this iOS XE? iOS XE is the version of the iOS XE that runs on Linux. iOS XE is a version of the iOS that runs on Linux. So in these Catalyst 9K series switch platform, in all these Catalyst 9K series switch platform, we can run like this iOS XE actually. Right? Fine. Now, what is this? When we talk about the iOS XE architecture, this is how the iOS XE architecture looks like. So in typical iOS, in typical like Cisco operating system, Cisco Internetworking operating system, in a typical iOS, the iOS includes all the feature components like, everything to support the HA management interface, drivers, kernel, and everything was there onto the box itself. In iOS XE, actually, it is possible in iOS XE, it is possible to run the operating system as well as other hosted applications as well. Such as, for example, we can run the Wireshark within the box itself. iOS will be there. The complete iOS functionalities are going to be there. But additional to that iOS functionality, we can run different types of applications, hosted application onto the same box itself. For example, this iOS XE supports supports running of the applications in a containerized environment. Like we can run the applications within some container within the box itself. Like we can have like 1, 2, 3, 4 containers, and all these 4 containers we can run 4 different types of application, and all those applications will run on the same switch, same box. This container could be like LXC, Linux container, or kernel virtual machine, KVM, like any kind of container it could be. iOS XE is capable of containerized applications and run them on the network device alongside the iOS. iOS XE allows us to run the iOS as well as certain applications on the same box itself. Containerized applications can run onto the same box itself. We do not need to purchase a dedicated box for the same. Right? Service containers, like these are called service containers. Service containers are applications that can be hosted directly on the iOS XE routing platform, basically switches, instead of running them on different devices. Instead of running them on different devices, we can actually containerize, we can run these things called service containers, and we can actually host the applications right on there. We can run applications such as, for example, Wireshark. We can run, let's say, for example, we have a small branch. In this very small branch, we have only a few users. Like, maybe 10, 20 users are there. And these users are, accessing the internet. And these users are also accessing our other, corporate network. I want to enforce some sort of security for the same. I want to enforce some sort of security for the same. Are we going to install a firewall on that branch? We can do that. We can install a firewall onto that branch, no problem. We can deploy some other security appliances on this branch so that the communication from like inside to outside can be made secure. Or better, just do one thing. If you have, let's say, for example, an iOS XE box, basically a switch that runs iOS XE, what we can do, we can load some security applications onto the same switch itself, and then the switch can perform basic security inspection before passing the traffic to the next device. That is also possible. iOS XE architecture actually allows us to containerize the applications, different applications such as Wireshark, such as, for example, some security applications as well. So if you have an iOS XE box, we can actually run things such as, for example, Wireshark and security applications right on the same box. We don't need to add a security appliance for the same. So let's say this was a router, because routers also come with nowadays like iOS XE architecture. So if this is a router that is running on iOS XE, what can be done actually? What can be done? I can run, for example, like security application images on here. So that this router is allowed to, this router is able to form, this router is able to perform some basically security related things on here as well. iOS XE is capable of containerized applications, and they run these applications on the device itself right alongside the iOS. Service containers are the applications that can run directly, that can be hosted directly on the iOS XE routing platforms. So you need to have the compatible devices, you need to have the compatible hardware and the software. Hardware is okay, but the software must also be compatible with the SDA. You need to find the appropriate hardware and the software that can run onto that particular device. So yes, like if you do not have proper hardware and software for the same, it is going to be a very costly solution to implement the Cisco SDA. You need to purchase new switches, you need to purchase new softwares, you need to install them in your network, and you need to purchase the DNS center, purchase the ICE and all that. So it is not going to be a very cost-effective solution, not at least right at the point of deployment. Not at least like, at the point of deployment. Sooner or later, like after like 3-5 years, you will notice that the overall investment that you have done is going to be, it will prove like very cost effective, but not right at that point of deployment. It is going to be very costly, actually. It might be very costly deployment. Fine. So what devices are compatible with Cisco SDA? Catalyst 9K series switch platforms are compatible with Cisco SDA. Catalyst 3K series switch platforms are compatible with Cisco SDA. Catalyst 4K, 6K series platforms are compatible with Cisco SDA. ASR 1000 series router, ISR 4000 series routers, Catalyst 9800 series embed route, WLC, like 3504, 5520, 8500 series WLC, some access points, wave 1, wave 2 access point, like these APs. These are the devices compatible with the SDA. And you don't need to memorize it, actually. You do not need to memorize. You do not need to memorize what devices are compatible with what devices in the SDA. Because they have made actually, a website. From there you can check this information directly. You don't need to memorize it. No need to memorize it. Okay. So what is that website? From where you can check all these things? Just search SDA compatibility matrix. Just search this SDA compatibility matrix and just open the the first page that we have here. Cisco SDA compatibility matrix. This is the web page that you should open. And from there, you can choose, are you going to go for a new deployment of the Cisco SDA, or you are going to upgrade? So I click on the new deployment. Which release of the DNS center? Which release of the DNS center you are going to go for? 2.3.5 through 2.3.6. What is the What is the DNS center release that you have in your environment? So you have purchased the DNS center version 2.3.3.7. Click on that and submit. And from here, select the role of the device. I will click on all. I don't know what is the role. So I just selected all. I don't know at the moment what is the role and everything. And just click on submit button. And it will list all the devices. Every device compatible with the Cisco DNS Center version 2.3.3.7, which is also a recommended release. And see, these are all the devices that are compatible. So ICE, Identity Services Engine, like this is the version, ICE version, like starting from all the way 2.4, patch 14, 2.4, patch 13, 12, 11, 10, then 2.4, patch 10. Like these are the ICE versions that are compatible with the DNS Center version 2.3.3.7. Okay, fine. Then we are going to go for like next device, that is Fabric Edge, something called Catalyst 9200 series switch platform running on this iOS XE version. You can click on more and you can get what specific version has to be present on the device to support the SDA. This is the software version and this is the hardware platform. These are the models. These are the models supported for the SDA. Scroll down, go for the like 9300 series switch platform. You can check 9400 series switch platform. You can check like 9300 IE industrial switches, Catalyst 3800. These are all the switch platforms that are supported in Cisco SDA. Models and everything is written here. You can take a look at the model and the software version as well. No need to memorize. No need to memorize like what version is compatible with what version. Same, scroll down, like other platforms are there, such as, for example, some Catalyst 8000 series router. Some routers are compatible as well. Like, these Catalyst 8300 series at platforms, 8500 series, 9300 series switches. Like you can browse this list to see when it comes to wireless, for example, what devices are compatible. So 9800 series wireless LAN controller, these models, these are operating system version. Same goes for like 9800 series embedded WLC, AP Wi-Fi 6 access points, 9100 series AP, 9115, 9117, 9120, 9124. Like, and old access points as well. Wave 2 access points, for example, are supported with this release of the DNS Center. So no need to memorize it. No need to memorize it. Just go to this website. Just go to this website and find out like what models of the devices are supported with the SDA and what actually like devices are supported. What software is supported in the SDA as well. You can check this entire list from this website. Just search Cisco SDA compatibility metric. It will bring you to this website, and from here you can check all these things. Okay, so these are like in brief, we have written down here that 9K series switch platform, 3K series switch platform, 4K series switch platform. Like, these devices are actually supported here. Okay, fine. Now, the devices that we connect in between, like these devices that we have from the design point of view, these devices, we call that distribution layer. The devices that we have connected here, they provide the reachability from one device to other device, from one device to other device, one device to other device. These are called intermediate nodes. These devices are called intermediate nodes. These devices that we have, these are called intermediate nodes. And these intermediate nodes actually provide the reachability from one device to other device, but they are not part of the fabric. They are not part of the SDA fabric. They could be any device, doesn't matter. They could be like any device, like Cisco, non-Cisco, any device, as long as they are able to forward the packet based on the IP address, everything will work. No problems at all. Okay. These provides the intermediate nodes are those nodes in the SDA deployment that provide the connectivity between the fabric node devices, the devices that are part of the fabric, but these devices might not be part of the fabric itself. They are responsible to forward the traffic in the underlay network. Like they will receive the traffic, they will forward it, receive the traffic, forward it, receive the traffic, forward it. They are not part of the SDA fabric itself.
Sir, sorry, sir. Just one question. We got the distribution in between the border and the edge node. But Cisco not recommended that distribution is in between the border and the edge, no? What's the purpose, sir? Because my current company, they have so much distribution in between border and the edge, because that distribution is doing only underlay between the border and the edge.
Yeah, that is fine. That is fine. But what if like we have some servers and all those like devices connected onto that distribution switches? I don't want to offload like all the functions on the border devices. I want to have like, for example, some servers, some like, for example, control plane nodes and all those devices running. And I also want to have some control plane nodes in the network, and I don't want to have the border nodes having the same functionality. So it is completely your choice. Like if you want to have the intermediate nodes, if you want to have this distribution switch where you can connect maybe your servers, you can connect, let's say, for example, DHCP server, DNS server, and other servers. You can connect like, for example, some other devices which are referred to as control plane node, which are part of the SDA. If it is required, then you can have it. Like it's not mandatory that you want to have.
Yeah, that's what I can't understand, sir. Because current environment, we got so much distribution, it's not doing anything, just in between, like intermediate switch. That's what I can't understand, the distribution role. What's the role, main role is? Because we got all the servers on the... We got all the servers, ICE, wireless, everything on the Fusion network, like outside the service.
You can have that. Like if you want to have centralized services such as DHCP DNS, you can have that. In that case, there will be no role of these intermediate devices. You can like connect your border node directly to the S devices. Like you need to do the cabling and all those things again, do the configurations and everything, and that will be fine. Completely your choice, your design, your choice. Like you can have either.
Okay, sir. But my question is, we got currently on the distribution switch, there's any issues if you are putting unwanted distribution between the border and the edge, like a troubleshooting or point of failure, any issues, sir? Because I can't understand what's the main role of the distribution. We are not using for any server, just putting the distribution and then connecting to the edge.
Distribution switches provide the aggregation point for the access layer devices. If you can do the same on the border nodes, it's okay.
Okay, sir.
Okay. Can I say something here? Yeah, from experience, we always design infrastructure and tried not to have a distribution layer, but they were already added in infrastructure or in buildings and campuses where the fiber limitations were there. So it is more to do with the fiber infrastructure and how it is laid out. Like, for example, you can have 5 or 6 different buildings in a small campus. And in each one of those buildings, you will put in a distribution layer switch, and all the access cabinets will connect to them. And then from the distribution layer, you will have outdoor fiber going to your centralized core infrastructure. So I believe over here as well, it's doing the same purpose. I'm coming from a traditional network, not from SDA.
I get that. Yeah. That could be the use case. That could be one of the use cases. Yes. Definitely.
Okay.
You will have long haul fiber between core and access, and then you will have single multi-mode fiber within the building itself.
Access to the access. Yeah. That could be one of the use case as well. But the main point is that these intermediate nodes could be anything. Like they don't even need to be part of the SDA design, like SDA. What I say, like infrastructure itself. Like there could be normal traditional devices terminating the connectivity from the border node to the edge node.
Okay, sir. Understand. Because whatever the previous mod he explained is, I think it makes sense actually. Because we have the troubleshooting issue between the distribution and then border and then the edge.
I can hear you. So from a traditional infrastructure point of view, when someone is designing the infrastructure, the cost is one of the big elements. And as I
Yes.
mentioned, a single mode fiber cable and single mode fiber modules that go onto the switches, they are almost double the price of a multi-mode
Yeah. Yeah. Hmm.
SFP. So,
Hmm.
so when someone is designing and trying to keep costs down, so they look at all these elements.
Hmm.
Like from an architecture point of view, does not make any difference, but from a cost point of view, it can have a
Hmm.
huge impact if you have, let's say, 100 access switches or 200 access
Hmm.
switches. So, and if you need to run a multi-mode fiber or a single mode fiber, the costs are almost 30-40% more in case of a
Definitely. Yes.
single mode fiber if it needs to go outdoors and stuff. Yeah. So that's why, from my experience, we used to
Hmm.
do it in that way. Yeah.
Okay. Yeah. Yeah. Oh, thank you.
Yeah, that makes sense. Yes. So all that will matter is the reachability. As long as these devices that are what we have labeled as border devices and the devices that we have labeled as the edge devices, they are able to connect to each other. They are they are able to contact. They are able to connect to each other using any traditional routing protocol, anything like EIGRP, OSPF doesn't matter. As long as there is a reachability between them, it will just be okay. Like these devices should be able to forward the packet based on the IP, and that is the only requirement of these on these intermediate nodes. They can be like they might be Cisco devices, they might not even be the Cisco devices. They must have the routing capabilities, and that will be sufficient actually. They are what we are going to call part of the underlay network. They are going to be part of the underlay network where you can connect, like, for example, for this particular branch, for this particular, let's say, for example, headquarter, we can connect like a few services on here. We can connect like our control plane node, control plane node, for example, some devices on here as well. As long as these devices are capable enough of forwarding the packets based on the IP, that's enough. That's okay.
Yeah, just a quick point over there. You said routing capability. Is it routing capability or switching capability? Because routing means layer 3 and switching is layer 2.
Routing capability. Actually, the point is that even if the switching capabilities are there, it will work fine. But the fact will, like, typically we will have the routing capabilities there. They will be like the layer 3 switches. Like we will create either we can create the SBI or we can create like the L3 interfaces and all that. We typically say routing capabilities. Like they should be able. Cisco recommends having the layer 3, like complete network as at layer 3.
Yes.
So I would say like routing capabilities.
All right, thank you.
But the point is that even if, let's say, for example, from the switching point of view, if you think from the switching point of view, let's say, for example, these devices, these interfaces, like, for example, these interfaces I have configured as layer 3 interfaces, layer 3 interfaces, layer 3 interfaces, layer 3, layer 3, layer 3, all of these we have configured as the layer 3 interfaces. So packet will move from the source IP, destination IP, source IP, destination IP. If these devices are capable enough of forwarding that packet, it's okay. Even if we have not configured like any, IP address onto those switches. Typically, since Cisco recommends that having this layer 3 routed access layer, like, as per their recommendation of the Cisco SDA design, they say that you should have the routed access layer where all the way from the, like top to the bottom, like all the way from the core access distribution, everything is layer 3. Typically, what happens, like at the distribution, we have our routing meeting with the switching. So they say like, no, now you go for the complete like layer 3. So from that point of view, I would say like it is routing capabilities. But even if like they are able to forward the frames, if I say from one point to the point, they will just be good enough. Now, in these devices, you don't require any special chip, any special like UADP hardware or anything. Nothing special is required. They could be Cisco, non-Cisco devices. All they need is a basic routing capabilities so that they become the part of the underlay network. These are what we refer to as the intermediate nodes. So we have some devices here.
Sir,
yeah.
So just one question. That means that the intermediate node, we can use any device. It doesn't use any Lisp, any VXLAN, just an underlay.
Yeah, any device.
Okay. Okay, sir. Thank you, sir.
Yeah.
And sir.
Yeah.
Also, to the intermediate nodes. Suppose if I do have the
regional or domestic side, wherein like I do have the two point-to-point links with those, and uh, even we can connect these those two cross campus links to these fabric switches, or
As long as you are able to provide the reachability, it will be okay.
okay, okay,
As long as you are able to provide the reachability somehow using fibers, using like any technology, it will be okay.
okay, got it.
Fine. So we have these physical devices, these devices that are compatible with the Cisco SDA deployment. These devices, on these devices, we are going to set the roles. And there could be some devices that are not the part of Cisco SDA, like, design. They are what we refer to as the intermediate nodes, which are more like part of the underlying infrastructure or the underlay network. And we also have some devices that are designed specifically for non-carpeted environment. Non-carpeted environment, that is like that is like some sort of warehouse, plant farms, and other like some those kind of industries where like installing a typical simple switch is going to be like it might not work properly. Like some hazards are there onto that environment, and if you install a typical Cisco switch, like if you install a typical normal switch, like it might go down in some days. It might be you might face some problems on those switches. So there are some special devices. Cisco has created some special devices for those non-carpeted environment. Non-carpeted environments are non-carpeted environments are those that are hostile to the switches, such as like, for example, warehouses, plant farms, and other like some hazards, like hazardous like environments, where like if you install a typical like a Cisco Catalyst switch, it might work for some days, and then after that, since the environment was not suited up for that deployment, like it might go down. So they configured this thing called extended nodes. These extended nodes, we can put like these some switches that we can purchase, and we can install these extended nodes into those non-carpeted environments. To extend the SDA to the environment that is hostile to the traditional switches or normal the SDA switches, in fact, to extend the SDA to non-carpeted environments, extended node is going to connect to the fabric edge node, and the fabric edge node will be managed by the DNS center. So right here on this edge node, we are going to connect extended node EN, or we also have a variation of the extended node called policy extended node, where we can push the policies as well. So we can connect, like, for example, from here, from this edge node. Edge node is the node. These, just to give you the basic idea, this fabric edge node are the devices that we can compare within the traditional network with the access layer devices. In the traditional network, we have these access layer devices. In this SDA network, we are going to call them the edge node or the fabric edge node. So these when we are talking about like these, when we are talking about these non-carpeted environment that is hostile to the normal like switches, there we can install these extended nodes. These extended nodes are going to connect to the fabric edge node. These extended nodes are going to connect to this fabric edge node. And we can also have this thing called a policy extended node, where we can push the policies from the DNS center as well. So here, for example, this fabric edge node is being managed by the DNS center, and this fabric edge node connects to this extended node. EN stands for here, the extended node. So to extend the SDA to the non-carpeted environment, an extended node is going to connect to the fabric edge node, and the fabric edge node is going to be managed by the DNS center. Note that these extended nodes itself are not compatible with the SDA, and they cannot run protocols such as VXLAN. So like, we are not going to directly manage these extended node from the DNS center itself. We are going to connect these extended node onto the fabric edge node, and we are going to manage the fabric edge node from the DNS center. Like these are the platform. These are the devices that comes under these extended node category. Like industrial Ethernet, switches are there, 3300, 3400, 4000, 5000. Like these are some industrial Ethernet switches. Catalyst digital building switches, CDB switches, all the models of the Catalyst digital building switches are considered as these extended node. And then we have Catalyst 3560, a PoE, some switches are there that can be considered as the extended node. We also have this thing called a policy extended node for enhanced security and segmented scalability. We can consider using a policy extended node because scalable group policies can be enforced onto that particular devices. So we have normal extended node that cannot run any security related policies. And then we have policy extended node where we can deploy the policies based on those like scalable groups, SGTs and all. So we have like normal devices compatible with the SDA. We have some intermediate nodes not compatible with the SDA, might be Cisco, might not be Cisco devices. And then we have some special devices that are designed for these non-carpeted environments that are hostile to these switches operations, such as warehouses, plant farms. And these switches, these devices that we can install on those locations are called extended nodes, called policy extended node. The difference between the extended node and the policy extended node is that the extended node is going to be like it cannot run any policies based on the scalable groups also, and the policy extended node can run like those policies based on like scalable groups. Security policies can be enforced onto those devices.
Sir, that means external node means it's a legacy network or?
No, it is, these are some, no, not legacy network. Like it is basically some like warehouses, plant farms, where if you install, like maybe we have some machines on the warehouses and the plant farms, and all these machines are needed to be connected onto some switches. And those switches like that, those switches we want to manage from the SDA, right? That was the aim.
Yeah.
But okay. The problem is that on those like warehouses, plant farms, maybe we have designed some sort of network in that warehouses, plant farms as well. But the problem is that like on those devices, on those locations, we cannot install a typical Cisco Catalyst switch because that environment is not very, very good in that location. It might be the environment is a little bit hostile. So if we install those typical Catalyst switches, like it might go like out of operations within some weeks, maybe. So they created specific devices that we can install onto those locations. Let me show you how it looks like. So we can install those devices into those locations, and those devices will connect to the Fabric as node, which is being managed from the DNS center.
Yes.
So, extended nodes SDA. If I search, it looks something like this. Let me show you.
Yes, we got external node in the edge connected to the edge node. I can't understand. It's using VXLAN or Lisp or something like that.
No. Those are not. Those are just traditional. You can consider those switches as just normal traditional switches. Those cannot run VXLAN or anything. They will just receive the traffic, send it to the edge node, and the edge node, since it is running like the VXLAN and all those things. So from there onwards, is going to start.
Okay, sir.
Right.
Yeah.
So it looks something like this here. Like this is like industrial Ethernet switches, like 3300 series switches. This looks something like this. These are switches that we can install in those, like for example, non-carpeted environment, and these are going to connect to the uplink Fabric as nodes, and that Fabric as node is being managed by the DNS center actually.
Okay, sir. So that means we can't push any policy to the extended node.
If you have policy extended node, then yes, we can push some policies on there. But if it is a normal extended node, no, we cannot push any policy directly on the extended node.
Okay, so I have to log in. I have to manually configure all those VLANs, all those stuff.
Yes, definitely.
Okay, yeah. Thank you, sir.
Yeah. Okay. Now. So we have some Catalyst, again, just to repeat, we have some normal like Catalyst 9K, 3K, 4K, 6K series switches that are compatible with the Cisco SDA deployment. We have some wireless LAN controllers, some access points, some routers that are compatible with the SDA deployment directly. Then we have some intermediate nodes that are that are being used to provide the connectivity from the S device to S device, S device to the border, S device to the control, they are not part of the SDA fabric itself. They could be Cisco, they could they might be Cisco devices, they might not be Cisco devices, does not matter. As long as they are compatible to perform the routing and everything, it is okay, it's fine. Then we have some, for non-carpeted environment, we have some extended node and policy extended node that we can install in those non-carpeted environment. These are not managed by the DNS center directly. They will connect to the fabric edge node, and the edge node is going to be monitored. The edge node is going to be managed by the DNS center. Fine. Now, okay, so we have all the devices, fine. We have all these devices. We have, we have like SDA switches, we have WLC, we have access point, we have some intermediate nodes. We have, let's say, for example, some like these extended nodes, pulse extended nodes, all those things. And we have built our network. Let's say we have built our network in this fashion. Let me show you. I will open the same topology that I used in the last class. So let's say we had all the devices, we had everything. And let's say, for example, we have built our network and it is looking something like this. Where is that topology? It is looking something like that. Okay, something like that. So here in this deployment, for example, here we have our access layer devices. We have here our distribution layer devices. Here we have our core layer devices, and these core layer switches are going towards two edge routers. One edge router might lead us towards the known external network such as data center headquarters, and one router might lead us towards a known external network such as internet, cloud, public cloud. We have, like, for example, deployed our DNS center maybe right here. The DNS center could sit anywhere, like it could sit anywhere. The WLC could sit anywhere. But like just for the representation purpose, we have deployed our wireless LAN controller here onto this switch. We have deployed our DNS center connected onto the switch. I can place it on here. I can place it on here. We have two routers here as well. These two routers are going to act as something called control plane node. We will just talk about that in a moment. From the SDA, so we have all our network. We can have like some just for the sake of wireless as well. Let me just quickly let's say for example, here we also have at the very edge. Let's say for example, we also have some access points, right? So on let's say for example, each switch, we also have some access points connected, and these access points that we have connected here, they are being managed by the wireless LAN controller that you can see right here in the picture. I'm not sure that if we have the option of the, I would say the extended node in this software packet tracer. We might not have any option of that, but you can consider that there are some extended nodes as well that is going towards, let's say, for example, the LAN network. Let me represent it with something like that. Where is that switch actually? Let me represent it with, we have it. Here, IE, here. We have that. In this packet tracer software, we have this IE switch, that is labeled as this industrial Ethernet switches. So considering that we have somewhere like we have some non-carpeted environment in some place, we have like here, for example, this switch as well. And here then we can, here on this device, we have multiple ports, and here we can connect like a few devices as well, something like that. Okay. So the point is, like we have like different types of network in like we have wired, wireless, like we have like, mix of all that. We have all the devices, we have done all the cabling and everything. We have made sure that all the devices are reachable to all the devices. We have made sure that the reachability and everything is there. Once we have done the connection, once we have made the reachability, once every device is reachable to every device, once the devices are reachable to the DNA center and everything, once everything is there, now we are going to create our SDA fabric. And when it comes to creating the SDA fabric, we are going to set the roles on the devices. The SDA fabric will include some roles onto the devices. The SDA fabric will include some roles onto the devices. We are going to set total 3 roles onto the devices. We can set the role as fabric edge node. We can set the role as fabric control plane node and fabric border node. On the SDA fabric, we can set these 3 roles: fabric edge node, control plane node, and the border node. Okay, here. Once we have all the devices, once we have made the reachability between the devices, once we have made the reachability from the devices to the DNA center and everything, then what we are going to do? We are going to actually set the roles onto the devices. There are total 3 roles that we are going to set on these switches. And additionally, if your switch supports maybe embedded wireless LAN controller functionality, then we can set the wireless embedded WLC role onto the switch as well, or we can have a dedicated device for the same as well. So fabric edge node, fabric control plane node, fabric border node, and the fabric enabled wireless LAN controller. Fabric edge node is the place in your SDA design where the end users are going to be connected. Where these end users are going to be connected, like this switch, this switch, this switch, all these switches are set in fabric edge node role. Here is where your wireless access points are going to be connected. Here is where your those special switches are going to be connected that are designed, that are manufactured for those non-carpeted environment, IE series switches, for example. Catalyst digital building switches, for example. So the fabric edge node is the place where the wired users get connected to the network. Fabric edge node is the place where the access points get connected into the network. Fabric edge node is the role. Fabric edge node is the device where your these special switches, such as like industrial Ethernet switches and everything, they get connected into the network. Typically, you can compare this with the access layer devices. In a traditional network, we had this thing called access layer. Here we have this same concept called fabric edge node. So fabric edge node provides connectivity for the wired endpoints and the access points to the SDA fabric. They are responsible. Okay, forget about the next line. Okay. Now, what happens whenever any of the device comes online? Let's say, for example, this device comes online and this device sends any traffic to this particular fabric edge node. The fabric edge node is responsible to register the information of this device. It is going to refer to as endpoint. It is what we are going to refer to as endpoint, and its IP address or the MAC address is going to be referred to as the ID. So this fabric edge node is responsible to register this endpoint ID, which is like, IP MAC address somewhere in the network. It is responsible, this fabric edge node is responsible to register. The fabric edge node is responsible to register the endpoint that is what we have connected here in the network. It is responsible to register that endpoint information somewhere in the network. Let's call this endpoint as A. The fabric edge node is going to register somewhere in the network that the endpoint A is connected to me. I'm going to call that S1. Basically, this fabric edge node, when it detects that the endpoint is connected to it, it is going to register the information that this endpoint actually A is connected to me. In reality, both of them are going to be some IP address. Okay. Then what happened? On some other fabric edge node, and another endpoint comes online. So this fabric edge node is going to register this information that the endpoint B is connected on me, switch number 2. Okay. Similar to that, anytime any endpoint comes online, it is the responsibility of the fabric edge node. It is the responsibility of the fabric edge node actually to register this information somewhere in the network. Why? Because now when, let's say, for example, the device B wants to communicate with device A, packet will arrive onto this fabric edge node. The fabric edge node has no idea how to reach to that B. It has no idea of like the destination, sorry, no idea how to reach to A. It has no idea how to reach to A. It has no idea how to reach to the endpoint A. It will ask someone that, do you know how I can reach to A? That device will respond that, yes, I know how to reach to A. If you want to go to A, do one thing, go to switch number 1. So now this device will send, it will, forward all the traffic towards the switch number 1. And switch number 1 will receive it, and then it will hand over that traffic towards the other LAN, other end user. Again, let's take more realistic example. This device has an IP address of 10.1.1.1. There is a loopback configured onto this switch with the IP address of 1.1.1. Here we have a device with the IP address of 10.1.2.1, and here we have a loopback configured with the IP address of 2.2.2. The device comes online, device sends some data, the switch is going to register the information. The switch is going to register this information that 10.1.1.1 is connected to 1.1.1.1. This device comes online, this device gets that information. This device detects that the device has come online and this is its IP address. The device is going to register this information that 10.1.2.1 is connected on me, 2.2.2.2. The place where this registration is done is what we refer to as control plane node. The control plane node in the Cisco SDA is actually where this registration is done. The control plane node in the Cisco SDA is the place where this registration is actually done. Registration of endpoint ID. Registration of the endpoint ID and its associated switch IP address. In technical term, it is what we refer to as endpoint ID. In technical term, we call this as RLOC. RLOC stands for routing locator, switch IP address in short. RLOC is just IP address of the switch. RLOC stands for routing locator. So there is a device designated in our SDA deployment called control plane node. That control plane node is responsible to receive the endpoint registrations and maintain a sort of database. And now, let's say the traffic needs to go from 10.1.2.1 to 10.1.1.1. Traffic will arrive onto this switch. This switch actually has no idea how to reach to 10.1.1.1. So this device will ask the control plane node that tell me how can I reach to 10.1.1.1. The control plane node is going to check its database and it will say that if you want to go to 10.1.1.1, you need to go to 1.1.1. So now this device is going to forward all the traffic that it has received towards 1.1.1.1. And while forwarding the traffic towards 1.1.1, it is going to perform some extra encapsulation onto that particular data. When the traffic is received onto that 1.1, this extra encapsulation will be removed and the traffic will be sent towards 10.1.1.1. And the same process will repeat when the traffic goes from 10.1.1.1 to 10.1.1.2. Now read this line. It says, the fabric edge node are responsible for registering the endpoint ID that joins the network and encapsulates the traffic in the fabric network. And the control plane node provides a mapping system that manages the endpoint to device relationship. Like what endpoint is connected to what device, that relationship, that information is maintained on a node called control plane node. It is they are like an essential component of the SDA fabric, because without them, like your SDA fabric will not be able to operate. Control plane node has to be there. Consider it as if you are good enough with the traditional network, consider these as DMVPN hub. In the DMVPN hub, we have the information, if you remember, of the tunnel IP and its associated NVMe IP address. Here you can consider them the same. The control plane node maintains a database. In that database, it will include the information about the endpoint ID and its associated public IP address. It's associated its switch IP address, not the public IP address, switch IP address. Why it is done that, why they have done that, like we'll talk about that later in our network layer. But this is the role of the fabric edge node and the control plane. Okay, what is fabric edge node? What is fabric edge node? Fabric edge node provides first hop services for the users connected to the fabric, just like the access layer switch in the traditional network. Fabric edge nodes act as the default gateway for the end users. It is also responsible to perform. It is responsible to identify and authenticate the endpoint using techniques such as static authentication, .1x, Active Directory, whatever. When the end user is joining the network and we have set some sort of authentication, it is the responsibility of the fabric edge node to perform the authentication of the endpoints using like maybe .1x, Active Directory, user ID, password, or whatever. It is going to register the information that a particular endpoint, IP and MAC address is connected on me. This information it is going to register onto a device called control plane node. Control plane node will have the IP to RLock and MAC to RLock mapping, based on which it will be able to know that this IP has this MAC address. Register endpoint information to the control plane node. Perform encapsulation, decapsulation, decapsulation of the data when the traffic is sent and received onto the device. Whenever the traffic is sent out of the fabric edge node, it will be encapsulated. When the traffic is received on the fabric edge node, it will be decapsulated. Okay, fine. Now, one more thing, which is like, quite unique to this SDA. If we have, for example, 3 fabric edge node and we have 3 users there, all of these users, let's say, for example, belong to the same, let's say, VRF, same VN, we call that in terms of SDA VN, virtual network. Let's say, for example, we have created a VRF called Corp. In terms of SDA, we call that VN, virtual network. Let's say we have created a VN called Corp. In this VN Corp, we have our corporate users. So this is one interface that is going towards a corporate user, part of the VN Corp. An interface going towards the corporate user, part of the VN VRF Corp. Same here as well. All these devices will have, of course, a different IP address so that they can communicate to each other and the rest of the network completely fine. But for this device, this is acting as the gateway. For this device, this is acting as the gateway. For this device, this is acting as the gateway. On all these three switches, same IP address will actually be configured as the default gateway for this user, and for this user. The IP address of the default gateway remains same on all the fabric edge node for a particular VN, virtual network, or call that VRF. And that is why this kind of gateway implementation is what we refer to as any cast gateway. Yeah. Go ahead with the question. Berlin,
sir,
I cannot
before you.
I cannot hear you actually if you are saying something. I think you are on unmute, so you're not audible actually.
It's audible now. No problem.
Oh yeah,
So,
it is.
So these three fabric edges, right? They are all in different locations, right?
Could be on different locations. Yes.
So will that not be any issues if they use the same default gateway?
No. Think about it. Like, see, the gateway IP is only relevant to the same location, right?
Yes.
When we talk about even from the traditional network point of view, the default gateway IP address is completely like significant in the local broadcast domain only. When the traffic is received onto this fabric edge node, after that there is no use of that default gateway IP, because then the routing table and everything will be looked up to forward the packet towards the next devices. So they use this concept of any cast gateway, which says that the default gateway IP for a particular VRF, for a particular VN, will remain same across the entire SDA fabric.
So if default gateway is same, so the computers can also be same at both the locations, right? For example, 1.2.3.4, they can use at both the locations.
You can use it on both the location. Like, the point is that here, it is possible in this Cisco SDA that whatever subnet we have configured here, the same subnet is going to run here, the same subnet is going to run here. We can switch.
So here is my question. So 1.2.3.4 is the IP address of a computer that exists in all these three locations.
No. I did not say that.
Okay.
I did not say that. I said that the gateway IP, gateway switch, gateway IP will remain same everywhere. The PC IP will remain different everywhere, of course. Like every device will have its own IP address. If they want to reach to any other destination, they will send the traffic to their respective gateway, and from there the traffic will exit there.
So which means the subnet can be different. The default gateway subnet can be different, and the computer subnet can be different, right?
No. You are not getting. See, the point is that this is a network. In this network, we have this device configured with the IP address of 1.2.3.4, right? So the default gateway that we have configured here is, let's say, 1.2.3.1, which is the IP address of the same subnet, right? Then we have same VRF on this device as well. This device will have a different IP, such as 1.2.3.5 maybe, but the default gateway will remain 1.2.3.1. Default gateway will remain same.
Okay, so this SDA itself ensures that the sites should not have same client IPs, right?
That because that is not ensured by the SDA. That is ensured by the DHCP server that we have in our SDA.
Okay.
Because if you are going to set the IP manually, then you have to make sure of that. But if you are using some DHCP servers to provide the IP to all the devices in a my SDA deployment, then it is the responsibility of the DHCP server to allocate different IPs on all these devices, but the same gateway on all these devices.
Okay, got it. Understood.
Yeah. Yes, Srinivasan. Yeah. You can let me know. Yeah.
Yeah, sir. Just you mentioned that all the EID will register to the control plane. What about if I have the two control plane? We have to make sure which one is the. If I have the two control plane,
we don't set any primary, secondary. Like if there are two control plane nodes, both will remain like active.
Same active.
Yeah,
okay, sir. Other question is for the endpoint. If I am using the DHCP, how long once the edge device will update the EID information to the? Does any particular time or because
No,
DHCP
as soon as the edge node receives any information from this device, like any packet from this device, because this edge device must know that a particular IP and MAC address is connected onto the LAN side of it. So as soon as it receives it, it will register it. Oh, sorry,
okay,
it will register.
Okay, if I restart the edge device, the same device will getting the different IP address. It will register to the control plane. That's correct, no?
Because the entries will have some time, right? Like the entries are not for undefined time period, so the entries might get wiped after some time. So somehow, like if the device has been removed, or if the device is still present onto that device, the information has to be updated on the control plane node as well.
Okay, sir. So we can manually refresh that RLOC logs or something like that. Because sometimes we can't ping that IP address for the end device.
We can check that. We can check with configuration commands, but logs will not. We can check with some configuration commands.
Not logs, sir. Just clear or refresh that. Forcefully update the EAD information to the RLOC server.
That we can check with the configuration commands.
Okay, but we can't force.
Not that I know of, like actually.
Okay, sir. Because whenever we are restarting the edge device, we can't ping the EAD IP address. We have to shut down the port. We have to open the authentication, and then again we have to put the authentication back. Somehow the RLOC server doesn't have any information.
Switches, like you're talking about from this switch point of view, right?
Yeah, that switch I can ping internally because it's the same broadcast domain. From the control plane or from the Fusion network, I can't ping the end device. So when we restarting the edge device,
that like when you have, if let's say for example, if you have restarted the device and until all the authentication and everything happens, like I think like you will not be allowed to ping from any external network to that particular end device, and your traffic will come to this fabric as node, and then it will get dropped. Like it will until the proper authentication and everything happens onto this fabric as node from the end device point of view, the communication will not be allowed from the device.
Okay, sir. Yeah. Thanks, sir.
Yeah.
Before we proceed, can you just review the slide one more time, from the beginning?
Which one? This slide? Same slide?
Same slide. Yeah, because you had so much discussion, so it's just a bit confusing. So it will make
no issues. So the point is the fabric as nodes, like this is like the place where we are going to connect our end users. We are going to connect our access points. Here we are going to cover. Here we are going to connect our those extended node, policy extended nodes. As soon as this fabric as node, as soon as the fabric as node detects a device, it is going to register its endpoint ID, which is IP address or MAC address, with its own IP address onto control plane node. This device detects that a device has come online. It is going to register its endpoint ID with its RLOC address. We call that RLOC towards the control plane node. Same thing will happen on here as well. Now, when the device, let's say, for example, this device needs to communicate with this device, packet will arrive on this fabric as node. The fabric edge node has no idea how to reach to this destination. It will ask the control plane node. Control plane node will check its database. It will inform the fabric as node that, oh, if you want to go to that 1.2.3.5, you need to go to 2.2.2.2. And then the fabric as node is going to perform some encapsulation on the data and send the traffic towards the fabric as node number 2. Here it will be decapsulated and sent towards the end user. And the same process will repeat in the reverse direction.
Why is it encapsulating it? What extra information is it adding?
VXLAN. That is why Like when the traffic arrives on this fabric edge node and the traffic is sent towards the other fabric edge node, that extra encapsulation that is being done from this fabric edge node is that VXLAN, information like the VXLAN tunnel and all. Because of like, some extra encapsulation will be done. Because of that, like we get some extra functions such as, for example, same subnet can live on both the switches.
Understood. Thank you.
Okay, this is fabric edge node. What devices are compatible with the fabric edge node role? These are the devices compatible for the fabric edge node role. No need to memorize it again. Just open this website, same website, just open SDA compatibility metric, go to the very top and select, instead of all role, select the fabric edge node and submit, and you will get the result, what devices are compatible with the fabric edge node role. 9200 series switch platform, 9300 series switch platform. We have 9400 series, 9500 series, IE switches, 3800, 3600. So the point is that here we can see like these are some switch platforms that are supported for the fabric edge node. 92, 93, 94, 95, 96, 36, 50, 38, 50, 4500, 65, 68. Even in these, not all the models might be supported. Some models with a specific supervisor engine line card has to be there. You need to check it from the compatibility metrics. There are different models of, let's say, for example, 3650 series switch platform. Some came way before, some came like way before, like the other one. So not everything is going to be supported. You need to check it from the SDA compatibility metrics. What platforms are supported for the fabric edge node?
Sir.
Yeah.
So is the SmartNet licensing comes under the SDA, and like how we can like in large enterprise network, how we can maintain that, like
maintain what exactly? Licenses?
Yeah, licenses. Like
licenses will be discussed later. Licenses will be discussed later on. Licenses we'll talk about later on. At the moment, we are just talking about the hardware that is required to build our physical infrastructure. We'll talk about the licenses later on. There are two types of licenses that get installed onto the device. One is like the base license, perpetual license, and then the DNA license. So we'll talk about the licenses later on. At the moment, just the devices that we need to use to build our SDA network. Fine. So how to enable a device for the SDA role? Very simple. How to enable the device with the SDA role? Let me show you on that same portal, same like dcloud that we used earlier. I will go to the same dcloud portal and let me show you how can we enable this role fabric edge node onto a device. Considering that we have built our network, we have made all the reachability and everything. If you want to enable the fabric edge node role onto the device, all you need to do is to just go on that particular switch and just enable this checkbox. Right? Let me quickly show you.
So one doubt. So can we make, suppose we have an edge node. So can we change that role to a border node or control plane node?
Not actually. Like once the role is set, if you want to reset the role, you have to remove the device from the fabric and set it again. And like, can you set multiple roles on the same device? Yes, you can, but you have to check it from the data sheet again if your device supports like more than one roles or not.
So the models differs based on the roles also, right? So for example, if I am purchasing a device,
reverse. Roles based on the model, not the models based on the roles. See, we have specific switch models where we can set the roles. So not all the roles are, can be set like on all the devices. So okay. Like typically, for example, if you try to set like more than 2 roles, like on some devices, it will not be allowed to set like all the roles. In some devices, it will be allowed to set all the roles. So like based on the device models, we can set the roles onto the devices.
Okay. So if I am purchasing a switch that is capable of edge node, and there is also a possibility that I cannot make that switch as a border or a control plane mode, right?
If you, let's say for example, you are purchasing a switch that is, let's say, at least 9500 series switch, right? It can act as the edge node. It can actually act as the control plane node, as you can see here, right? And it can also actually act as the border node. In fact, almost all the switches you will notice are allowed to operate like in all the nodes, all the modes. Yeah.
Okay.
But
the ISR and ASR cannot act as a edge node, right? The routers.
No, ISR like the border nodes and the control plane node, not the edge nodes.
Okay.
Edge nodes like switches typically, like not the routers.
Okay, thank you.
Fine. So if you need to set the role, all you need to do is to just to go to the device, just go to that network device, and there you can set the roles directly. You just need to enable this checkbox and click on the add button, and it will set the role on there. Remember that once you have set the role, it will not allow you to remove the device role. You cannot set another role. You have to, if you want to set the another role, you need to remove this device from the fabric, and then you need to set the role again. Unfortunately, this is not opening up at the moment. I will try to open it again. It's just not loading up. Not sure what happened. I will try to open it on the the other browser. I'm trying it on the other browser meanwhile. But it is that easy to set the roles onto the devices. No configuration required. We don't need to do any configurations actually. Just open the device, just open your DNS center, go to the fabric, go to the provision, and there you can directly set the roles onto your particular device. No configurations required. And once you click on add button and deploy, the DNS center is going to push whatever configurations are necessary to set that role. Whatever configurations are necessary, DNS center is going to push that to the devices. Right. So for example, I will click on this DNS center. I will go to the provision. I will go to the SD-Access. I will go to the fabric. I'm basically redirecting. I'm going towards the particular switch fabric that we want to change in some geographical location. Maybe, for example, such as San Jose. For example, in this location, I have multiple devices and I want to set the roles onto those devices. Right. We'll do that from the scratch when we build a topology. But let's say, for example, this is the topology of the San Jose network. Right. So this is, let's say, for example, the topology of San Jose network. And you can see here, like EN stands for edge node. EX, like you can click on that. This is like extended node, like, EX extended node, like, So just click on that. For example, click on this EN button and you can just check this box up. And once you check it, like add, and just click on deploy button, and then it will push this deploy button and it will push the configurations onto that particular device. Whatever configurations are needed to make it as an edge node will be pushed onto that device. And let me show you one more thing. Here we have like these much number of edge devices, right? So edge node, edge node, edge node. We have multiple extended node, and all those things. Forget about it. Focus on these edge node, edge node, edge node, edge node, edge node. Okay. This is transit control plane node. Forget about it. Click on this button. And here you can, here you can like remove the device from the fabric as well. You can remove the device from the fabric and reset the role later on, because maybe, for example, we want to set some other things. Like we want to configure the border node on this device. Maybe we want to configure the control plane node on this device. It will just not allow us to do that because the role is assigned. So you need to remove the device and then reconfigure the device. No, we are not interested in that. Just check this. Just check this. Where is that? Do you see the interfaces? Fabric, port channel, not the port channel, advisories here, details. It's actually not showing the IP address. This is the switch IP address. Not interested in that. It is not showing us the lot of statements. What I'm trying to see here is the IP address of that SVI that we were talking about actually. There used to be like a, sorry, here. So you go under here and check this. See what happened. For the employees VN, for the employees VRF, this switch has configured some, VLAN here, and it has configured some IP address on here as well. The IP address belongs to 10.16.52 subnet. The name that we have for the VN, it looks like this itself. If I go on the another switch, let's say, for example, if I go on the next switch, actually, if I go on to the next switch, I will see the same actually thing there as well. Can you see here the SVI? It's not showing actually. But anyway, so if you go on to this device, let's say, for example, if you go to this edge node onto this device, you go to, let's say, for example, configuration, actually the same subnet IP, same exact IP will be configured on here as well. Same exact IP will be shown here as well. Can I run the command? Show IP int brief? No, it is not allowed. Anyway, like we are not able to validate that here. The IP is not being shown, but rest assured, like the IP address will exactly be the same for the VLAN 1021 on all the 4 fabric edge nodes, on all these 3 fabric edge nodes. Whatever IP is here, whatever IP is here for this particular VN, the same IP will be there on this switch and this switch, and that will act as the gateway for the LAN, for the end users and all these extended nodes. Right? Actually, it used to show, actually, I think like they have put more restrictions on that, but it used to show here, like right on here, it used to show the IP address that is actually configured on that particular SPI. Just for the moment, rest assured that here, when we check the configurations of that particular VLAN 1021, the IP looks like from the subnet 10.16.52, and exact same IP actually is there on all the 3 nodes. So this is how we can set, the device in the fabric edge node role. This is how we can remove the device from the fabric edge node role. That's it. Removed it, done. Click on this device again. Like, see, here now you can set the roles. So if you are setting it at the edge node, can we set the control plane node? Not allowed. We cannot just leave the things on edge node and we cannot do that. Not allowed. Can we enable it only at the control plane node? Yes, it is allowed. Can we set it for both control plane and border node? Yes, it is allowed. No problem. Can we set it like edge node and the border node? Yes, it is allowed. No problem. Is it allowed to set all the roles? Doesn't look like it is allowed to set all the roles. So again, the point remains the same. You can choose like what role you want to assign to this particular device. As soon as you select that role, click on deploy button. DNS Center is going to push all the necessary configuration onto that particular device that will make it the fabric edge node. This is how we set actually the roles onto the devices. Right? This is the fabric edge node. Okay, fine. Next is fabric control plane node, which we will talk about after some break. So control plane node in our SDA fabric, it keeps a database. It runs a host tracking database. It basically maps the location information. The control plane node has a database. The control plane node has a database. That database is going to map the endpoint ID to RLOC mapping. So this RLOC is also referred to as the location routing locator. Eventually, basically, this is the IP address of the switch where that endpoint is actually connected. So a simple host database that maps the endpoint ID to the current location, along with some other attributes as well. When we use the configuration command, we'll be able to verify that. A host database supports multiple type of endpoint lookup, such as IPv4, IPv6, MAC. So IP to RLOC mapping, IP MAC to RLOC mapping, IPv6 to RLOC mapping, all those things will be there. It is going to receive, this control plane node is going to receive the registration requests from the Fabric Edge node and also something called a border node. From the border node as well, this control plane node is going to receive the registration request messages. Receives endpoint ID to map registration request from the control plane, from the Fabric Edge node and from the border node. For the known IP prefixes, all the prefixes that are known to our destination, all the prefixes that are known to our implementation, those will be registered on the control plane node by the border node and by the Fabric Edge node. And when the Fabric Edge node asks the control plane node about the RLOC of a particular IP, it is the responsibility of the control plane node to give the information to that particular device. So it resolves the lookup request from the edge node border node to locate the destination endpoint. So the Fabric control plane node is responsible to propagate. Fabric control plane node is responsible to propagate the information. It is responsible to send the information that this endpoint actually lives onto this particular router to the Fabric Edge device. What are the platforms supported for the control plane node? Again, go to the compatibility matrix and check what platforms are supported for the control plane node. Just go to the website and there, instead of looking for now edge node, just go for the control plane node. Remember that the same devices that we can use for the control plane node can be used for the border node as well. So select it, submit, and it will list all the devices that are supported for the control plane node and the border node. There are routers and switches both available on this role. We can have a router running as the control plane node. We can have a switch running as a control plane node and also border node. How to set the control plane node functionality? Same thing. Just visit just go to that portal. Just visit that page here. And let's say, for example, we want to set the control plane node onto the device. Just click on the device. It is an ISR 4400 series router, for example. Just click on that device and set the control plane node. And just click on Add button. That's it. Add, deploy, and it is going to set. The DNS center is going to push all the necessary configuration that is going to mark this device as the control plane node. Nothing extra. Just visit the GUI. Just go to the GUI, graphical user interface of your DNAC, and just set the role on there. Whatever configurations are needed to be pushed, they will be pushed onto the device from the DNS center itself.
Sir.
Yeah.
Do we need to create the template in order to have the standard configuration to be pushed, or it will take automatically from the other switches and only change the IPs and it will
just
push
make
on
the reachability. Do you have to do the configurations on the switches, configure the protocols to make the reachability? That's it. No extra configurations required.
Okay, but in order to push the configuration, like production configuration, we need to have or the template kind of thing, right? So
templates and everything is completely different thing. Like, we can push the configurations with the help of the template that will be discussed later on. But if you are not push the templates or anything, still it will work. As long as you have set the reachability, as long as the reachability is there from the device to the DNS center will be able to push the configurations on there. At the moment, we are just talking about the role. We are not talking about anything extra, like the templates or anything other.
Okay.
Fine. Again, we can have multiple control plane node. Just go on there, enable the control plane node, deploy. Like I said, you will be able to do quite a lot of things on this dCloud lab. So I would encourage you to, explore this dCloud Cisco and then try to set the rules as well.
Is it open lab, sir?
Yes, I have it. Yes. Refer to the last recording of the last day. I have explained it there. How to access this lab. It is already explained there.
Okay.
Yeah. You don't need to book any lab for the same. It is like it is instant demo. Like it's not a scheduled one. So you can just log in and just start doing the things. Okay. Now, the final role that we have in our SDA that we can set on the switches is called fabric border node. The last thing that we have here is called fabric border node. Fabric border node that we have in our SDA deployment, they are going to allow non-SDA devices to connect with our SDA devices. For example, here we can have, let's say, for example, a data center running on traditional network, maybe some public networks such as internet, cloud, public clouds and everything, data center, headquarters and all. Like they are advertising certain prefixes onto here. Here we are also receiving some sort of default route and everything. So these border nodes, these devices that we have set on the border node role, these devices are going to facilitate the communication from outside the SDA to inside the SDA and vice versa, from inside SDA to outside SDA. With the help of the border node, actually, the communication between SDA and non-SDA devices are, supported. Okay, fine. Now, there are 3 types of border nodes that we can set. What is the border node? The border node, fabric border node, connects our SDA fabric to outside network or non-SDA network. It is the entry and exit point of the data traffic going in and out of the SDA fabric. Makes sense, okay? There are 2 types of network where we can connect. We can connect to our known destinations, such as, for example, headquarter, data center, branches, all these locations. And then unknown networks, such as, for example, internet, public cloud, AWS, Azure, and all those things. So there are 2 types of outside network that we want our SDA network to connect. We can have like a known network. We can have an unknown network. Known network such as a data center or a traditional branch. Unknown network such as internet or some public cloud. Now, how are we going to connect to these known and unknown destinations outside our SDA? How have we configured our border node to connect to these external destinations, external known and unknown destinations? Based on that, this device can either connect to only known destinations, unknown destinations, both of reachability and everything is completely on us. How have you made the reachability? Maybe we have a dedicated border node. Maybe we have a dedicated border node that is connecting to just external known destinations such as data center headquarter. Then we have, for example, a border node that is connecting to outside networks such as, for example, unknown destinations such as, for example, public networks such as, for example, internet or the, let's say, this public cloud. Yeah, public cloud. There are 3 types of border nodes. There are 3 types of border node. One border node that we have is called internal border node. One border node that we have is called external border node. And one type of border node we have called anywhere border node. So we can have a dedicated device, that connects only to the known destinations outside the SDA, such as our data center headquarters and all. This type of device is what we refer to as internal border node. Internal border node is the device that connects our SDA network to outside the SDA network. A dedicated border node that connects our SDA network to outside the SDA network, but that is not under our control, an unknown network, such as, for example, internet public cloud. So that kind of device is what we refer to as external border node. Okay. And if we have connected a device in such a way, if we have configured this border node in such a way that it connects to both known and unknown destination, then it is going to be referred to as anywhere border node. Not necessary to have two different border nodes for two different roles. Not needed. We can have like one, for example, border node for both the roles as well. Now, how do we configure it? What is the difference between, first of all three border nodes? How they operate, how these, if we have configured a border device to be the internal border node, how it is going to operate with the other one. Okay, let's talk about that. Internal border node, first of all. First thing first, the internal border node. The internal border node connects our SDA network. The internal border node connects our SDA network to outside the SDA network, but that is under the outside network is known to us. It is like data center, branch office. So what will happen? This data center and the branch offices, they are going to announce all of their prefixes here onto our branch on a router. This router is going to connect to this border node here. And this router is basically going to perform that handoff of these prefixes into the SDA. Like, so let's say subnet A, B, and C, X, Y, and Z. These subnets were learned onto this particular router. The router has advertised those subnets to the border node. Border node has the IP address of 1.1.1.1. This border node is going to register all these prefixes to the control plane. It is going to register that if you want to go to A, B, C, X, Y, Z, you can come to me. Internal border node imports, they register these external subnets to the control plane node. These are all known destinations outside our SDA. These are all known destinations. The internal border node is going to learn all these subnets and it is going to register them to the control plane. So the control plane node actually knows that if I want to go to ABC, XYZ, this is where exactly I need to go. It is going to import and register known IP subnets from outside into the control plane mapping system, except the default route. Except for the default route, it is going to import and do all the things. Also, this border node is going to export all of my SDA subnets 1, 2, 3. It is going to export all the SDA subnet 1, 2, 3 towards this router. This router is going to advertise those subnets to the data center and those branches so that they know that these subnets actually live in somewhere in the remote location. For this purpose, for this exporting purpose, what protocol are going to be used? Like this, from this border node to this router, we will use some protocol to export all these subnet like 1, 2, 3 subnet towards the traditional data center branches, these location. We can use any traditional protocol for the same, as long as that protocol is supported, as long as that protocol supports VRF. It's okay. Like, as long as that protocol has the support for the VRF, we can use any protocol. However, in reality, the protocol that we will use is the BGP, is the border gateway protocol. The protocol that will be used here on the border node and this router responsible to accept all the routes from there, advertise all the route to there, is going to be the BGP protocol. It is going to be border gateway protocol. So internal border node connects to any known destinations outside the SDA network, such as, for example, data center, firewalls, wireless LAN controller, branches, and all these devices. It is going to export all the internal IP addresses to the outside using some traditional IP routing methods, not the VXLAN, not the Lisp. And it is going to import and register all the outside subnets like XYZ123. It is going to import and register all the outside subnets towards the control plane node as well. It imports and registers known IP subnets from outside into the control plane mapping system, except for the default route. And we also have like the handoff between like the traditional and the SDA might also require like VRF and SGT mappings from one SDA domain to, let's say, for example, non-SDA domain as well. We might also need to hand off like, not only the VRF, but we might also need to hand off the scalable group tags and some other parameters as well. It is the responsibility of the border node to also advertise, let's say, things such as, for example, scalable group tags and everything as well. Now, external border nodes that connect to outside unknown destinations, they are not going to. This is an unknown destination, such as, for example, internet or a public cloud. So I am going to learn maybe all these prefixes on this router, or if not, then I will just have a default route. Who cares, like, to learn all the routes? If you have like all the routes, then it's okay, no problem. But like, of course, you might not have like all the possible routes to reach out to all the destinations on the internet. So that's the default route will be fine. But even if, let's say this router is receiving all the routes from the outside network and the routes are getting advertised to this device, this border node, it is not going to import. It will not import external routes into the SDA domain. This external border node, outside world, or the external border node is gateway of last resort for these devices to reach out to any unknown destinations. Default route. It connects our SDA network to outside SDA network that is not under our control. Some unknown destinations, such as, for example, public cloud or the internet. It is going to export all the routes. This device is going to learn all these routes. It is going to export all these routes to the router, but it is not going to import any route from the outside to the SDA network. It will just be used as the default gateway for the SDA devices. Nothing more than that. It does not import any routes. It is used as the default route. If exact route is not available, then this will be used as the default route to reach out the external destinations. Questions? Let me know. Doubts? You are not audible again, Berlin. You check the mic once.
No, we cannot hear him either.
Okay. Remove the mic. Remove the mic. If you're using any headsets, remove it. Like sometimes that fixes the problem.
I had to switch mics. I have multiple mics, so I switched between them and then it started working.
Yeah, might be the issue. You can use the chat box if it's. I'm still not able to hear you, Berlin. If still the problem is there, you can use the chat box for the question. Meanwhile,
so it seems that the only difference between internal and external is the default route. In the internal one, you will not have a default route, and in the external one, that it is the default route.
Also, the difference is that the external border node is not going to import any outside prefixes into the SDA.
Exactly. Yeah.
And it is still going to import, like it is going to still export all these prefixes of the SDA to outside, but it is not going to import any out because too many prefixes of the outside destinations.
Indeed.
Am I audible now?
Yes, you are audible. Yeah,
yes.
Now so.
So there will be two border nodes, internal and external. So the external will be providing default route to the SDA infrastructure, right?
Yes. Yes.
And you have also mentioned that it doesn't import any routes from the SDA infra. Is that right?
from like in the HCNs, like it is not going to import any external routes from outside in the SDA.
Okay.
Like I am still like, say, this is my one of the subnet, this is the second subnet, this is the third subnet, A, B, and C. I am going to advertise the subnet information towards I am going to export these subnets towards the traditional network, but I am not going to import any outside subnet into the SDA.
I got it. Yeah.
Yeah. And
what is that SGT?
SGT is scalable group tags, based on which we can configure the policies for our endpoint users. The ICE, it is a part of ICE. We'll talk about that later on when we talk about ICE.
Okay, thank you.
One more thing I would like to say here. It is like, see, here also, right here also, even though this actually border node connects to our known destinations such as data center and branches, is it actually mandatory that I want to learn all these prefixes as it is here? Not exactly. If I want, see the subnet A, subnet B, subnet C, X, Y, Z, I am learning all these prefixes, but I am not going to import these prefixes into the SDA. Because anyway, I'm going to be, I can configure this as the external border node for even our known external destinations as well. As long as that device can be used as the gateway of last resort, every traffic will reach out to this device, and this device already has that information, so packet will still be forwarded, no problems at all. Like what I'm trying to say, this doesn't matter. What I'm trying to say, this does not matter. Actually, what matters is like what type of border node we have configured here. If it is configured to be an internal border node, then it will learn and register all the external networks into the SDA, so that this control plane node knows that if I want to go to ABC, XYZ, here is where I have to go. And if we have configured it as an external border node, then how does that? Even if we have configured it as an external border node, this device is not going to, it will have all the information. This border node will have all the subnets. It will just not import it into the SDA network. But since this device is configured as an external border node, it is being used as the gateway of last resort. Everyone can still use that device to reach out to these external destinations. So the only point that matters is that are you willing to, do you want to import the external routes into the SDA or not? If you want to, configure it as an internal border node. If you don't want to, configure it as an external border node. And the best I would say, do both. Like you want this device to actually import all the external routes as well as become the gateway of last resort. So configure it as the anywhere border node. Typically beneficial in the situations when the connections get terminated, where we have like a single border node and the connection is getting terminated from the router going towards our traditional network and the internet as well. So I will learn all these like DC HQ prefixes. I will register them to the control plane node, and I am also going to act as the default gateway so that the traffic can also reach to the internet. Anywhere border node or internal plus external border node is one all exit point for any known and unknown destination. It connects to the unknown IP destinations outside the SDA fabric and to the known destinations such as DC. It is going to import and register all the known subnets from the known network, and it is also going to export all these SDA prefixes to outside network. Also, this will act as the gateway of last resort. How can we set it now? Same thing. Let's say that this is our border node, right? Let's say this is our border node. Let's say this is our border node. So I think I need to, okay, anyway. So when you configure this border node has to be configured. You will need to configure the border node. Remember, control plane node, no need to configure. Edge node, no need to configure. Configure by mean configurations. We don't need to do any configurations, but when it comes to the border node, we need to do the configurations regarding import and export. This is the border node. This is our fabric border node. It is going to receive the prefixes from the traditional network and import it into the SDA. Receive the prefixes from the SDA and export it into the traditional network. Here on this border node, we will need to do the configurations. So if I remove this device from the fabric and I reset it, I try to configure it again, you will need to configure it. Like you click on this device, maybe this device is our border node. It is receiving the routes from our routers maybe. I will click on this device and I will, then as soon as I check on this box, it will ask me to configure it. Right here, we have that concept of handoff from traditional to the SDA, from the layer, like, from the layer 3 point of view, like the routes from the SDA are going to be exported into the traditional and the traditional to the SDA. That handoff is what we refer to as the layer 3 handoff. And this border node can also be used to hand off the VLANs. So let's say we were migrating from the traditional to the SDA, right? And the migration like of some branches is being done. Now the problem is that a few users, like a few switches have been migrated into the SDA, and those switches now, on those switches, we have some users. This is a switch that has been migrated into the SDA, and it has a few users in a corporate VM. And for this corporate VM, the switch we have configured, not we actually, DNS Center has configured an SVI called 1024, maybe, any random number. The problem is that the same corporate user also exists in a traditional network because the migration is still going on. It will take a few more days to complete. So meanwhile, the same corporate users are also hanging around in the traditional network. They have the same subnet, 10.1 subnet here, 10.1 subnet here. But the problem is that here we have our gateway is like, for example, this switch here, our gateway is on this switch here. We have a different VLAN configured here. We have a different VLAN configured. So when the migration is happening, actually, you might also require to perform this thing called layer 2 handoff. In the layer 2 handoff, what we do actually, while doing the migration, if some traditional users are still part of the traditional VLAN, such as 100, 200, and in some places we have deployed this, SDA and all, so that at that time of migration, actually, at that time of migration, we might want to map the SDA VLAN with the traditional VLAN so that the devices in the SDA can understand that, oh, we are still talking about the same corporate user. So that is done on this layer 2 handoff. In the layer 2 handoff, what we do actually, we map the traditional VLAN with the, we map the SDA VLAN with the traditional VLAN. And we tell that, okay, this is the interface of our border node going towards the traditional switch. We'll talk about that later on. But, the point is that 2 types of handoff we need to do. One is called layer 3 handoff. One is called layer 2 handoff. Layer 3 handoff typically deals with the routes, and layer 2 handoff typically deals with the VLANs. In the layer 3 handoff, when we enable the layer 3 handoff, right here, actually, we can set if this device is a internal border node, external border node, or anywhere border node. So see very carefully. If, for example, while setting the rule, I have not enabled any check here. I have not enabled any check. No checks here. So it means it is internal border node. Internal border node means like this device is going to learn all the prefixes, import it into the SDA. It is going to learn all the prefixes and export it outside the SDA. This means internal border node. If we have not checked, if you have not, enabled any checkbox here, it will be known as the internal border node. If I click on this button, if I checkbox this and I check on this one, it is what we refer to as external border node. What do we mean by that? It means that this device will act as the default gateway and it will not import any external route. It is the property of the external border node. So see, if you mouse over it, it says, this is the gateway of last resort. Any unknown traffic will be sent to this fabric border from the S device. after the node role is configured, you cannot change the border type. Then if you check on this one, check this box if you do not want to import the external routes from the other routing protocol, such as BGP, to the control plane node. So if you have checked these two boxes, it will be like external border node. And if you have checked this box only, and if you have not checked this box, then what we say, it is called anywhere border node, because it will import the external route as well as it will act as the gateway of last resort. See here, right here.
Yeah. So on the anywhere border node, how will it know which are internal routes that needs to go into the control level?
Exactly. Okay. So for example, okay. So in this topology, where is that? In this topology, let's say, for example, these devices I have configured as this device I have configured as anywhere border node. So this device is connected to, let's say, this router, which is going towards the internet. And here we are connected to the router that is going towards our data center headquarter and all. So obviously, like this data center headquarter and all these locations, they are going to announce a few prefixes. Those prefixes will be received by this our site edge router, and the site edge router is going to advertise those prefixes to this particular router. Those prefixes that I have received from my site edge router on this border node, and I have registered those prefixes on here. I have said to go to A, to go to B, to go to C. Where we had to go? We had to go to like 1.1.1.1. Also, this router maybe is receiving a default route from here so that it can reach out to the internet. And I want that this router, this device should be reused as the gateway of last resort. So we have checked that box of external node as well. So it means basically means that this device right here is also going to be acting as the gateway of last resort. So now let's say any end user tries to reach to B. Packet will arrive on the Fabric edge node. Fabric edge node has no idea how to go to B. It will ask the control plane node how to go to B. B will say go to 1.1.1.1. Okay, so when the reply comes, this Fabric edge node will redirect all the traffic to the border node. And from the border node, the traffic will reach here because I have the route. If from here, the traffic has to go to, let's say, for example, 8.8.8.8, packet arrives on the Fabric edge node. Fabric edge node asks the control plane node, how can I go there? Control plane node says, I don't have any entry about the same. I don't have any entry. But do one thing, go to this 1.1.1.1. I don't have any entry regarding the same. Negative reply. We'll talk about the technical term later on. The Fabric control plane node has said, I don't know how to go there. But do one thing, here is our, as per the configurations done by the administrator, this device is being used as the external border node. So do one thing, send all of your traffic to the Fabric border node. And as a result, this device is going to again redirect the traffic to here. And on here, since we have a default route, using that, it will be redirected to here. So to answer your question, there is no way that these devices will know that if they are trying to reach to the internal or the external networks. If they get the positive reply from here, then also the traffic will reach here. If they get the negative reply, then also the traffic will reach here. And eventually it is on the border node to redirect the traffic here or here.
Okay, thank you. My next question is about the control control plane. How many control
nodes we can have in the network?
Yeah, how many nodes should we have, and how should we distribute them in our infrastructure?
At least, like, it is recommended that when we talk about a site, it is dependent on the Fabric site actually. So it is recommended that at least one control plane node has to be there in one Fabric site. For the redundancy purpose, have at least two. Right. So for example, like we are going to organize our entire network that we have configured all around the world. This is, let's say, site number 1. This is site number 2, site number 3. It is recommended, like here, at least one control plane node, at least one control plane node, at least one control plane node you have. And for the redundancy purpose, it is recommended to have 2. We can have more than 2 as well, but at least one. And for the redundancy purpose, it is recommended to have 2. A site configuration, a fabric site is incomplete without this control plane. You will need to have the control plane node on the particular device. So it is based on the fabric site rather than, based on like the entire location.
Right. So each location should have a control plane node.
At least one, yes, definitely.
At least one. Okay.
Yeah.
And let's assume we have some sites with one control plane nodes, and we have some sites with two control plane nodes. And the site with one control plane node, that control plane goes down, so it can reach out to any other control plane nodes from another location.
No. That will not happen.
Right.
That will not happen. There comes a concept of a transit, like when we talk about connecting two or more branches together, there comes a concept of transit, and the transit can be an SDA transit can be an IP transit. So that thing will again be dependent on the configurations that we have done onto those devices, onto the branches. But if short answer, by default, no. We have to at least for the redundancy purpose, at least have at least two control plane nodes on the particular site for redundancy, high availability. So here, for example, in this diagram, if you go on in this diagram, for example, here they have created a lot of sites. You go to the design, you go to network hierarchy, and you can see that here in this D cloud, they have configured a lot of branches and a lot of sites, let's say here. So on every site, we will have, for example, Asia, Egypt, South Africa, North America, USA, California, Texas, Washington, New York. The point is that in all these locations, this is a site. In this site, we have a fabric. In a fabric, we will have in this San Jose fabric right here, we will have a set of control plane node, border node, and the edge node for a proper fabric operation. So you can check that from by going to the provision, SDA, sites. Right here, we create our fabric, and we can go to any any of the site that we have here, and we can notice that it will also give you a prompt. It will also give you some sort of warning that the device, that the particular site is not having any control plane node, border node, or something like that. So it will also give you some sort of prompt on there. Okay, fine. So we will need to have at least one control plane node, border node, and the fabric edge node, so that these things can be facilitated. And there are some switch models. There are some switch models where all the roles can be set on the same box as well, which is what we refer to as fabric in a box. Fabric in a box is a feature. If it is available onto your Catalyst switch platform, it will allow you to set all the roles on the same device itself. It will allow you to set all the roles on the same device itself. We can set the control plane node, border node, and the edge node all on the same device. It is very beneficial in a small deployment. If you have a small deployment, there we can a few routers, a few users are there, and we want to actually set, for example, some roles on the devices. The fabric in a box feature allows us to set all the roles on the same switch without the need of having more than one switch in the site. So in a small to very small deployment, actually, it is not, it is where the number of users are very less, number of devices are very less. There, this feature is actually very suitable. So on the same box, we are going to co-locate the control plane node function, border node functions, and the edge node function. Catalyst, for example, 90-303 switch supports that kind of deployment. A dedicated control plane node, a dedicated border node is very much beneficial in a medium to large scale environment, as it can improve the network stability for during both fabric site change management and even in the event that the fabric device becomes unavailable in the network. So we have multiple control plane node, we have multiple border node. If one device becomes unavailable, the other device is available to take the responsibilities. We have a dedicated device for the control plane node, we have a dedicated device for the border node, and we have a dedicated device for the fabric as node. This kind of deployment is very common in a medium to large scale network. But in a small scale, small to very small site where the number of users are very less, we can go for fabric in a box feature. We can enable all the functions, control plane node, border node, edge node. We can enable all the functions on the same device. Also, side by side, we can also enable the embedded WLC, embedded wireless LAN controller. We can enable the embedded wireless LAN controller. We can also enable like WLC functions on there as well. Embedded wireless LAN controller can be enabled on there. Dual fabric in a box means like two devices we have placed, and on both the devices we have configured the fabric in a box feature. However, it should be used if mandated by the existing wiring infrastructure. We can have like dual fabric in a box feature, like 290 series switches in a small location, and we have set all the roles on all the devices, on both the devices basically. So dual fabric in a box feature is also supported. You need to check the documentation. You need to go through the data sheet and find out if, for example, your device actually supports the fabric in a box feature or not. Not all the platforms support it, so you need to check it from the data sheet. I believe that here, not sure, do we have any, let me see, device where they have enabled like all the roles at once. So if I go on here and set the control plane node, border node, and the fabric border node, like here, we need to set the parameters for the handoff and everything, right? Once we have set all these things, see, it is allowing us to set all the roles on the same box. So it is possible, it is allowed. Not all the platforms support, such as 3650, 3850 does not support that. So you have to be very careful. Like you have to check the data sheet, you know, before you purchase a switch for a small or a very small location. And there, if you want to use that fabric in a box feature, first of all, you need to check the data sheet for the support of that particular feature.
And I can see we can enable wireless LAN controller here as well.
Likewise, we can also enable here, right here itself. We can enable the fabric enabled wireless LAN controller. Of course, like we need to download the WLC image, install it on the device, then, you know, do some configuration regarding netconf and all that. But yeah, it is completely possible that we enable the fabric WLC functionalities on the same box as well.
And we are going to touch a little bit of wireless in this training.
Definitely. I will show you how to onboard a wireless LAN controller in the SDA. And for that, I will be using the PNP process.
Okay.
So if the access point is in fabric, so similar to the wired devices, so the MAC address or the device ID will be sent using access point.
Yes. Access point, like not the AP one. The AP, let's say for example, the access point is connected on the fabric as node. And a user connects onto that AP, right? That user information will be given to, like, you know, the fabric. Of course, the AP will be. You can also check the things about of the AP on the WLC as well. That is on the DNS center as well. That is fine. But the client information is going to be sent from the access point towards that particular fabric as node, and from the fabric as node towards the upper DNS center control plane node.
Okay.
So like we can see, like, I'm not saying that we cannot check the information about the AP. We can do that. We can go to the assurance. We can go to, let's say, for example, health, and we can check, for example, network. We can check the number of network devices right from here, and we can see right here. So see, we have like a few routers, core switches, distribution layer switches, access layer, and right here we can see the APs. Click on the APs. There are 42 APs that are basically SDA capable APs. So those can be checked and managed from here itself. WLCs can be checked and managed from here itself. But when it comes to registration, when the client gets connected itself, the client connects itself onto the access point. The access point is going to learn its information, and that will get registered on the control plane node. It is also going to, the access point is going to inform the WLC about the same. WLC is also going to register it onto the control plane node. We'll talk about that in detail in the wireless section at the very end, but that is completely possible. That is completely possible. See here, AP. These are the access points that are there. Click on any access point, such as, for example, this. You will get a detailed information about that AP, as good as a dedicated, like, monitoring software here. All the issues and everything, all the events that have happened, like, things you can check from here as well. What are the users? What is the AP name? CPU utilization, uptime, and everything. So these are all the physical devices that we have here in our SDA infrastructure. These are the different types of devices and roles. Basically, this is it. This is it about all these physical layer in the SDA infrastructure. Next thing is that, okay, now we have all the devices. We are setting the roles and everything. That is completely fine. Now we will talk about the protocols that will be used in this entire process. Like, for example, just to give you a brief idea, when this device comes up and this fabric as node registers this information to the control plane node, it is going to use a protocol called LISP, Locator ID Separation Protocol. When this particular device tries to send some traffic to here, this fabric as node has no idea about the same. It will ask the control plane node, how can I go to that destination? It will also ask it via LISP. The control plane node will tell that, okay, if you want to go to that destination A, you can go to 1.1.1.1. That it will also do it via LISP. And when the traffic is needed, this is all control plane operation. So we can say that the control plane is built around LISP technology in our SDA. And when the data traffic has to pass, the data traffic has to be encapsulated as well. And that encapsulation will be done from the S device to S device with the help of a technology called VXLAN. So at the data plane, we use the VXLAN. At the control plane, we use the LISP protocol. And when it comes to enforcing the policies and everything, we are going to use CTS, Cisco Trust Sec. This is all going to be covered in our next layer. These are the platforms for the border node. You can, again, same thing. You can check the compatibility matrix for the same. And all these things are going to be like from the LISP, from the VXLAN, from the Cisco Trust Sec point of view, all the things will be covered in our next layer, which is what we refer to as the network layer. So here we will talk about the underlay, overlay, fabric, roles, protocols, VXLAN, LISP, ISIS, all these things from the underlay overlay point of view, we will talk about in our next class. Meanwhile, for today, we are going to do only this much. If you guys have any question, you can discuss. And we will continue from here, like in our next class, next week. We will talk about, just go through like chapter number 1, chapter number 2 of your official book, and to get a better understanding of all these things, and try to cover everything up to like these rules, like what type of rules we can set onto the devices. Try to do try to set some rules from this dcloud website from here itself. Later on, when we do the lab, you will be able to get like all those things in much more clear way. Then in the next week, we will start with our fabric second layer of the SDA architecture, that is the network layer, where we'll talk about fabric underlay, overlay, and the fabric network itself.